Good morning, everybody. Let's see what we have discussed first in the previous sessions. So first of all, we are learning about a tool called RapidMiner. So we have seen, first of all, introduction to RapidMiner. What is the use of RapidMiner? And then we have installed an application which is RapidMiner Studio. And how is the interface and what are the features of that particular tool we have discussed. And then coming to the data, we have some inbuilt default data present in the particular tool called RapidMiner, how to use the default or inbuilt data sources, as well as how to import the data. All these things we have discussed in our previous sessions. And coming to the EDA and data preprocessing. So EDA, you already know about that exploratory data analysis, which consists of 4 business moments. We have seen how to do those business moments in RapidMiner Studio as well. And then in data preprocessing, in yesterday's session, we have discussed what are the different steps present in data preprocessing and how to perform each of it in RapidMiner Studio. So we have discussed all these things in the last 3 sessions, and we have also covered few of the charts like bar chart or bar plot, box plot, scatter plot. All these things we have also seen in the previous session. So coming to the probability, we have discussed what is probability, what do you mean by a random variable, and what is probability distribution, and what is inferential statistics. Within that, I have also shown you an operator called as sample in RapidMiner Studio. Then the first business moment, which is measures of central tendency, and then measures of dispersion, which is the second business moment, which consists of which consists of standard deviation, variance, and range, and expected value. And also, as I told, some of the graphical representations like bar plot and histogram. And last, we have third and fourth moment of business decision, which is skewness and kurtosis, and box plot, normal distribution, and scatter plot. We have already seen these things. We will see one more time in RapidMiner Studio. So coming to yesterday's session, we have started discussing about data preparation, which is data preprocessing, which consists of data cleansing and organizing, how to clean the data and how to organize the data, and also how to convert one data type into another data type, which is called typecasting. And also, if you have duplicate records or duplicate columns present in your data, how to handle those duplicates. And coming to the outlier analysis, we have seen different methods to treat or handle the outliers like Winsorization, trimming, 3R technique, and so on. And also how to identify the outliers through standard deviation approach and also IQR approach. All these things we have seen under the outlier analysis. And coming to zero or near zero variance features. So a column, if a column is having the values of same type, which is, for suppose there is a column called age or there is a column called country, within that country column, all the records are belonging to only one country, which is USA. So we can ignore that column, which is nothing but zero variance features. And discretization and encoding. So discretization, as the name indicates, we are converting numerical into categorical, categorical into numerical, that is discretization and encoding. Coming to the missing values, if you have missing values in your data, how to handle those missing values? And what is feature selection and data scaling techniques, and what is transformation? So we have discussed yesterday all of these things. And once we will just go through the mind map and we will see all the things that we have learned one more time in RapidMiner Studio. Okay, so let me open the mind map. So here, this is the mind map regarding this steps that are involved in a project. So the first one that we have is business understanding. So in business understanding, as we have seen, the first thing that you have to do is record your business objective. And also you have to record your business constraint. Before going into the objective and constraint, first of all, you have to understand your business problem. Understanding your business problem, later on you have to record your business objective, and then you have to record your business constraint, and then the success criteria. And always it is recommended for you to write the objective and constraint using 2 to 3 words. And those words, and it should start with the data optimization terms like minimize or maximize. That is nothing but business understanding. After this is done, the second step that we have is data understanding. In data understanding, what we have data types, what are the different data types present, and how you are collecting the data. You are getting the data from primary data source or secondary data source. That is nothing but data understanding. And coming to the third one, which is data preparation, which we have seen in yesterday's session. So here data preparation consists of, first of all, EDA, which is exploratory data analysis. It is also called as descriptive statistics. So there are 4 business movements. The first movement, business decision, which is called as measures of central tendency, which consists of mean, median, and mode. And mean is also called as average, and mean will get influenced by the outliers. Whereas median is the middlemost value, and median will not get influenced by the outliers. And coming to the mode is the value which repeats maximum number of times. And it may be single mode. You may have single mode in your data, or 2 modes, or more than 2 modes. That is nothing but first movement business decision. And coming to the second movement business decision, it is also called as measures of dispersion. Measures of dispersion consists of variance, standard deviation, and range. And the third one that we have is third movement of business decision, which is skewness. Skewness talks about asymmetry of distribution. It may be positive, it may be negative, or it may be normally distributed. And coming to the last one, which is fourth movement business decision, it is known as kurtosis. Kurtosis talks about peakiness of the distribution. It also may be positive, it may be negative, and it may be normal. And coming to the graphical representations, we have seen there are different types of plots present: univariate, bivariate, and multivariate. Coming to the univariate plots, you have again different types in which we have seen the basic plots like bar plot. We have also seen histogram. Histogram, the primary purpose is to understand the shape of data distribution. And the secondary purpose is to identify the outliers. And we have also seen what is the difference between density plot and also histogram. Density plot is also called as kernel plots and smoothened histogram. We have also seen QQ plot as well as box plot. So box plot is also called as box and whisker plot, and the primary purpose of it is to identify the outliers. Coming to the secondary purpose of this chart, the box plot, is to understand the shape of data distribution. There are 5 quartiles or 5 number summaries present. That is minimum, quartile 1, median, quartile 3, and maximum. And in here, you can see the word called interquartile range, which means Q3 minus Q1. And coming to the next one, QQ plot. QQ plot is also called as quantile plot. Okay. And then coming to the bivariate, we have seen the scatter plot. This is about the graphical representation. And the last but one we have discussed is about data preparation or data pre-processing, or we can also call it as data cleansing, data wrangling, whatever the name that you want, you can call it. In here, we have seen multiple things, which is typecasting, changing the data type, and handling the duplicates, outlier analysis or treatment, 3R technique. 3R stands for rectify, retain, and remove, and masking and swamping, Winsorization, and trimming. That is outlier analysis treatment. Coming to zero and non-zero variance features, we will ignore the columns which is having the same entries throughout. That is 0. And coming to the categorical columns, we will talk about this 0 and non-zero variance regarding the proportion. But for numerical columns, we will work with the help of variance. And coming to the next one, discretization or binning or grouping, that is converting continuous data into discrete data. And dummy variable creation, I told you an example or the difference between one-hot encoding and dummy variable creation. And coming to the missing values. So replacing the missing values with any logical value is known as imputation. There are a lot of different types of imputations present, like mean, median, mode, random, hot deck, and so on. And coming to the variance, you have missing completely at random, missingness at random, missingness not at random. We have discussed everything. And coming to the transformation, when your data distribution is not normal or it is not linear, then you will go for transformation. Here also you have a lot of different methods in which we will go for Box Cox and EO Johnson depending upon your purpose. If your data set is having only positive values, then you can go for Box Cox. If your data set is having negatives as well as zeros, then you can go for EO Johnson. And coming to the data scaling or data shrinking or feature scaling, whatever it is, it will make the data scale free and unitless. I have shown you the standardization and normalization, what happens in the form of an Excel sheet. Okay, normalization, when you just normalize the data, it will just make the data where the minimum will be 0 and the maximum will be 1. When you standardize the data there, the average or the mean will be 0 and the standard deviation will be 1. And coming to the robust scaling, when you have outliers in your data, you can simply go for robust scaling to scale your data. So this is what we have seen in up to yesterday's session. So let's just see the overall what we have understood, how to do all these steps in RapidMiner Studio. Then we'll move on to the new topic. So let me open the RapidMiner Studio here. So here is our interface of RapidMiner Studio. So I will just create a blank process and I will start working on it. So first of all, we will start discussing about EDA. EDA, you already know there are 4 business moments. So what are the 4 business moments? First of all, let's talk about the first business moment. First, I will show you the first moment of business decision, which consists of mean, which is nothing but average. And also we have the next one, that is median and mode. So we will calculate these things first and then we will look into the next one. Just a second. Okay, first let's start discussing about the first moment of business decision, that is mean, median and mode. Okay, so first, in order to work on this first moment of business decision, I will connect with sample superstore. You already know sample superstore, which is the mostly used data set. So let us use that for this purpose. Okay, so I already have my sample superstore in one of the repository, which is in session repository. If you don't have it, you can import it. So in session repository, under the data subfolder, I got sample superstore. In order to work with the data set or data source, whatever it is, if it is an Excel or CSV, anything, you have to first drag it into the process. So what you can understand the namings over here, this is called as a process. Here you can see the name. So process is where you will perform all the steps in sequence and you will execute this process with the help of the start button on the left-hand side. So this is nothing but the run or execute. So how can you execute the process? Here, whatever the operators that you are using, you have to make the connections between them. At last, they should be connected to the response port here. After that only, the process will get executed. Okay, now let's see how to execute this process. So first of all, I have connected with sample superstore, but in order to execute it, I have to connect my output port to the response port. Now I need to execute my process. The execution is done. So totally in my example set, which means the data set is having 9997 records. So here records is nothing but examples, attributes is nothing but columns. So totally 21 columns are there and 9997 records or rows are there. Now I want to discuss about the EDA first. So EDA is nothing but 4 business moments or 4 moments of business decisions. So coming to the EDA, let's start talking about the first moment. Okay, the first moment basically, I want to show you how to do it in RapidMiner. So first, what I do is, I will just use the operator extract aggregates. I will use the operator extract aggregates. You can see the operator on the left-hand side. So depending upon your purpose, whether you want to clean the data or handle the duplicates, whatever your purpose may be, there are different types of operators which are built in RapidMiner Studio. So that is one of the feature. So I am just dragging my extract aggregates onto the process. Okay, I got my extract aggregates. Now, in order to execute it, as I told, the operators should be connected to each other. So the output of the first operator will be the input to the second operator. Now I will execute this process. You have to make the connections properly. And before executing, if you want to customize your operator, you always have to go for parameters. So if you are listening to the session for the first time, you may not understand the wordings here. So each and every operator here, which are using in the process, will have the parameters on the right-hand side, which is useful for customizing those operators. So here I want to customize extract aggregates using this parameters option. So what I want to do, I want to see not for all columns. I want to see only for a few columns. So I'm selecting subset here. So what are those few columns? So these are all the numerical columns present here. Why? Because I can't calculate mean. I can't calculate median for categorical columns. That is why it is showing only numerical columns. So for sales and for profit, I want to find out. Remaining else, I don't want it. So here I'm selecting my columns here, which is profit and sales, and click on the bottom apply. After this, I want to find out the mean and median. And remaining else, I don't want it because I want to talk about only the first moment business decisions. Okay, I want to calculate mean and median. So after checking in this mean and median, you have to execute the process. After executing it, you can see here the sales mean value, which is average value, is 229.777 and median is 54.384. This is how you can understand about the first moment of business decision, that is mean and median. So you can ask me, what about mode? But I did not select these values. In order to understand it, I will use an operator called as multiply. So I have one more operator, which is multiply. I will take this again into the process. So all the operators should be connected to each other. So I'm connecting sample superstore to multiply first and multiply to the output, which is response port. And later on, I have one more operator present over here. So I will connect this multiply second output port as input to extract aggregates. And then again to the response port. This is my process now. I have three operators. Multiply is an operator which is useful to create copies. Now I will execute the process. Now here you can see this is the original data set sample superstore. If you want to understand the repeated value for categorical columns, which is mode, you have to go for statistics. When you go for statistics over here, if you observe, these are all the columns, 21 columns present in the data set. Now, if you want to observe only for selected attributes, which is only categorical columns, then you have to use the operator select attributes. That depends upon your purpose. You can use as many operators as you want depending upon your purpose. So here, what I want to select, I want to select a subset of columns. What is that columns? What are those columns? Only categorical columns. Here, if you observe here, when I am selecting the columns in my data set, you can observe here the data types. You can observe the data types here. Hash is always a number. You already know it. It is always a number. Whether it is float or integer, it is a number. And here the product ID, this 3 circles is nothing but a string or a text data. And date is indicated with the calendar and time. This is date. So this is how you can understand the data types. Now what I want to do, I want to select only categorical columns. Why is it? Why? Because I want to see what is the most repeated one, which is mode. Okay, how can I do it? So I will select only the values or the columns or the attributes or features, whatever it is, which is belonging to only categorical. So I'm not selecting hash symbol. I'm selecting only categorical columns. So this profit and quantity is not categorical. Region is categorical. Segment is categorical. Ship mode, state, and subcategory. You can observe here the symbol coming for all these columns, which is nothing but a text. Now I'm click on OK. I'll click on OK. Okay, so here I have used sample superstore, and I just want to understand the difference between the original data set and also the aggregation values, which is mean and median. Now I want to see mode for the categorical columns as well. Then what I do is I will use the multiply operator, which creates copies of a particular data set. For one of the copy, I have selected only categorical columns, and I will execute the process. So now what happens? This is the original data set, which is having only categorical columns. If you see here at the bottom, out of 21 columns, now I have only 13 columns. Why? Because I have selected only categorical columns. So whatever the columns that you have here, everything is categorical. You can see it. Nothing is numerical here. Nothing is data type here. Okay, I got all the categorical columns. Now what? Now, if you go to the statistics, you can observe what is the most occurred one. What is the most occurred value, which is nothing but mode. You can see under the statistics within the results view, you can see here the most occurred one, the most. So out of all the customer IDs, 37 times I can see in 9997 records, the customer ID, this is this one. And also the most repeated segment is consumer out of the three. And the country, all the records is having only one country, which is United States. So 9997, you can see it here. And cities in 915 records, I can see the common city. So this is how you can understand the mode for categorical columns in RapidMiner Studio. So this is about mean, median, and mode. Now let's see what are the others present, like standard deviation, variance, and all. First, suppose if you go to the extract aggregates, you can see here the standard deviation, minimum, and maximum. You already know standard deviation and variance are similar, but one is square root and one is not. That's it. So I will just check out the standard deviation and variance. Variance is nothing but, range is nothing but maximum minus minimum. So now I'll execute the process. Now, if you see here for both of the columns that I've selected, which is sales and profit, the mean value, median value, minimum, maximum, and standard deviation. And if you want to see the skewness, you can see the skewness. That is third business moment. If you want to see the kurtosses, you can see the kurtosses and execute the process. So for every column that you select, you can check it out whatever you want and you can get the values. So if the skewness value is greater than 0, that is positive skewed. If the kurtosses value is greater than 3, that is also positive kurtosses. So now here you can understand both are positively skewed and positive kurtosses data distribution. That is not normal. Okay. So now this is how you can perform all the 4 EDA or descriptive statistics on data in RapidMiner Studio. And if you want to understand the data by plotting charts, like any of the visualization, like histogram, all of those things, in the results view, on the left side, you have visualizations present. In this visualizations, you can use whatever the chart that you want under this plot type, whether you want histogram, whatever it is, you can mention it here and you can select the columns here. Okay, this is showing only these values because this is not the original data set. So go to original data set. You can create any visualizations that you want. So I'll go for histogram. I did not select any histogram here, any column here, because I don't have any data here. So this is how you have to understand whatever that is present. Okay, so this is how you have to understand because I did not select any numerical columns to create the charts. That is why here I'm not getting anything under the visualizations. Okay, now let's see what are the different data pre-processing steps present and how to do it here in the RapidMiner Studio. So in this process, I want to delete the entire process. So no need to go to file and create a new process. You can just delete whatever you have created. Draw a box and click on delete in the keyboard. Simple. Now, let's check out what we have seen yesterday and we will start discussing about a new one. Okay, so first suppose I have a data set having duplicate values. So I have a sample data which is having duplicate values. Now I want to remove the duplicates. So first of all, we will see what we will see. We will see how to do, here I will write it here. How to do typecasting, which is changing one data type to another data type. And also, what else? How to remove the duplicates in RapidMiner Studio. We will see it here. how to remove duplicates and what we have seen yesterday. And I have also shown you how to detect outliers. How to detect the outliers, I've shown it to you. And also how to normalize, how to standardize. I've all shown it to you in yesterday's session. Let's see one more time how to do it. Okay, I have here a sample data which is having duplicates. So now what to do? Here, that is an Excel file. So I will remove the duplicates from that particular Excel. So I will use the operator read Excel here. So just drag it and drop it here. Now, in order to import the data, what you have to do? You have to double click on that operator and you have to use or select whatever the data set that you want. So I want the data set that is duplicates data set, which is this one, duplicate records data.xlsx. Now I will click on next. So here, if you see, there are duplicates present. What are the duplicate columns present here or duplicate records present here? If you observe the records 3 and 4, both are having exactly same. Both are having exactly same for all the columns, which means 3 and 4 are duplicates. And what else? So 7 and 9. So there are totally 2 duplicate records present out of 11. Out of 11 records, 2 duplicates are present. When I remove duplicate records from the original records, I should get totally 9 records only. So we will see how to get the 9 records by eliminating the duplicates here. Let me clear this one. After doing this, you have to click on next. If you want to format it, you can format. I don't want to change anything. So I'll click on next. Here, there are no problems. If you have any issues regarding not matching the data type and all, you can see that at the bottom. But we don't have any currently. So I will simply click on finish. Now this is done. If you want to understand whether you have imported the data properly or not, you have to execute the process. So I'm connecting my data set, which is read Excel operator, to the response port, and I will execute the process. You can see here there are totally 11 records and 4 columns. Now I will use the operator that is I will use remove duplicates. I will use the operator remove duplicates here. So simply I will drag it into the process. After that, you have to make the connections. So make the connections. If you want to customize, you can customize using the parameters. So I'm not checking on anything. So I'll click on it. So I'm selecting all the records. Based on all I want to remove the duplicates, I'll execute the process. So totally before there are 11 records. Out of 11, I have 2 duplicate records. Those are removed and now my output is having only 9 records. This is how you will eliminate or remove the duplicate records in RapidMiner Studio just by using 2 operators. And then what? And then you have typecasting. I've shown you yesterday. You have multiple operators like what? So here numerical. If you have numerical column and you want to convert it into binomial, you can use these operators here. And if you want to convert numerical into polynomial, you can just use this operator. So there are multiple operators which are already built in for different purposes. You can use whatever the operator you want according to your requirement. Now let's see how to detect the outliers. So here I will use the inbuilt data sets which are already present. I'll go to sample folder. I'll go to data subfolder and I will use the Titanic data set which is present. So this is not the data set that is present in my local machine. This is the one that is already present here. So in this Titanic data set, I don't want to choose all the columns. So I will use the operator, select attributes. Now you have to make the connection. So what columns or what attributes you want? So I want to include a subset of attributes. I will select a few here. I'll click on select attributes. Now I will select here number of parents, number of siblings, passenger fare, age, port of embarkation, ticket number. This is enough. I'm selecting few columns. This is some random columns, okay? So I'm click on apply. Okay, I've selected the columns that I want. Now, you can detect the outliers using detect outlier distance. But if your data is having different scales, I want to convert it into a normalized scale using normalization. I can normalize it. So connect your operator as input, and then I will use here the detect outlier distances operator in order to detect it. Connect these operators. Now what? After detecting the outliers, if you want to see the outliers, you can see it using filter examples. So filter examples, and then you can click on it. And in the filter examples, if you want to customize, you have to use the parameters option. So here I will add a filter. What? I want to show the outliers. Outliers is true. If you don't want to show the outliers, if you want to see only the normal data, you can go for false. Click on OK. Now, if you execute the process, you can see the outliers present. Maybe 5 to 6 or 6 to 10 or around 10, there may be the outliers present in your data. That is how you can find it. See? So these are all the outliers present in your Titanic dataset. That is how you will detect the outliers in RapidMiner Studio. And if you want to perform discretization, you can perform it. How to perform discretization here? So use sample superstore. I'm using sample superstore. You can use anything you want. And in order to perform discretization, I will use the operator discretize. So you can use discretize by size, binning, all those things, but I will use by default binning. So I will connect these operators. And if you want to customize it, you have to use the parameters. Now, I don't want to select all. I have to select only a single column. What is that column? That is sales column. And I don't want to choose anything. I don't want to choose anything. I will just remain this as is. I'm not changing anything. Now, if you want to execute it, you have to connect this to the response port and execute this process. Now, if you see here, there are two bins that have been created for the sales column. This is what discretization means. And if you want to convert numerical into binomial, numerical value, which is encoding or discretization, you can have different operators present here. And then what else we have seen yesterday? We have also seen normalization and standardization using different operators. So here again, I will use the iris data set, which was defaultly or inbuiltly present in RapidMiner Studio. So iris data set is present. Now I want to see the difference. So I will use the multiply operator. So I will use multiply operator. I'll connect these two and I will execute this to response port. After that, in order to perform normalization, you have to use the operator called as normalize. I have to use the operator called as normalize. And in the normalize or standardize, you can choose the columns that you want using here. But here, you have to choose range. Why? Because normalization, as I told, when you perform normalization, the minimum will be 0 and the maximum will be 1. So you have to go here using range transformation. So range transformation is just like normalization in RapidMiner Studio and execute the process. And after that, again, if you want to perform standardization, again take the operator normalize, connect the multiply to the normalize 2. And if you want to change the name of the operator, right click and rename the operator. I want to rename it to standardize. Okay. Now in this, you have to choose the Z transformation, which is nothing but standardization. What do you mean by standardization? When you standardize your data, the mean value or average will be 0 and the standard deviation will be 1. So see here and click on execute. So see here, this is here the original data set. If you see here, the values of this are very large, 5,105. These are not present in a single scale. So you can normalize the data. When you normalize it, your value will have minimum is 0 and maximum is 1. How can you understand whether minimum is 0 and maximum is 1? You can use extract aggregates, which we have seen before. So I will use this operator here. And I want to know only for all the columns, the minimum and maximum, because we have to understand whether minimum is 0 and maximum is 1 or not. So I will just uncheck rest of all and I will execute this process. So sometimes the connection may be missing, just connect it properly. After making proper connections, execute the process. Now this is the original data set. Now I have extracted the aggregates for normalization. And if you check here, the minimum will be always 0 and maximum will be always 1. And you can check it for the standardization as well. You can use one more operator, extract aggregates here, and you want to get only standard deviation, mean and standard deviation. Rest of all, you can uncheck it and execute the process. So this is how you will get the mean will be always minus 0 is nothing but 0, and standard deviation will be always 1, which is standardization. And the next one, that is normalization, the minimum is 0 and maximum is 1. This is how you will perform all these things in RapidMiner Studio. Just the operators, you have to understand the concept, when to use which type of operator, and when to use this multiply, all these things you have to understand the description of every operator. So you can use it according to your requirement. Now let's check what are present, like what is present in the further slides. We are done up to data pre-processing. Now let's check what is present in fourth module. Coming to the fourth module, we have here clustering. So what is clustering? What is segmentation? Clustering is also called as segmentation. So here, targeted marketing is the key of STP framework. STP stands for segmentation, targeting, and positioning. We will discuss everything in detail. First, let's see what is the agenda for this module. First of all, let's see what is the agenda here. We will understand what is supervised learning and what is unsupervised learning. So why we are learning this? First, let's check what is present in the mind map. So we have seen up to the third phase, that is data preparation. Data preparation is done. Once you are done with data preparation, which is cleaning your data, you can simply go for the next one, which is nothing but model building. So what is model building? Why do I have to do the model building? Whoever the students which are who are not belonging to DS may not understand this model building in the first time, but you will get it gradually. How to do it in RapidMiner is the most of the important thing that we are about to focus on. So before moving directly into the tool, we will understand the theory first. Okay, once you have cleaned the data, now you can proceed to the next phase, which is model building. So coming to the model building is also called as data mining or machine learning. You may have heard this word machine learning a lot of times before, but now let's see what is machine learning, what is there in that. So this model building is the phase which you will move on to once you are done with cleaning your data. And now it is also called as data mining or machine learning. So here you have two different namings that you have to understand, which is supervised learning and unsupervised learning. So we need to talk about the differences between supervised learning and unsupervised learning. Before talking about clustering and segmentation, we will understand these namings. Okay, and we have self-supervised learning, forecasting, and all these things. Before talking about all of these things, let's open our slides and check what is present in this particular agenda. We will talk about the clustering or segmentation. Before directly moving on to the clustering, we will understand the supervised learning and unsupervised and what are the differences present. And the clustering 101 and what are the different algorithms present in clustering and the distance measures and what is hierarchical clustering and what is a dendrogram. So we will see all of these things in detail, and also we will see one particular hierarchical clustering algorithm which is agglomerative today, and how to do it in RapidMiner Studio also we will discuss. Okay, so first of all, let's see what is present in the first slide. Coming to the first slide, you have supervised learning. So what is supervised learning? First, we have to understand these namings, then only we can move on to the algorithms. So what is supervised learning? Why do I have to learn this? What is the purpose present in supervised learning? Okay, so in supervised learning, there is training and validation. What is it? In supervised learning, you have training and validation. So here, you have some historical data. You have some historical data. First, suppose you have some data which is given by the customer. So that is nothing but historical data. So here imagine you have some historical data which is having multiple columns, which is also having an output variable and input variable. Like what, as I told before, output is indicated with Y and X1, X2, all these things indicates the input variables. So just like that, you have multiple columns and numerous records. This is nothing but historical data. For suppose if you have some historical data given by your customer, and this historical data is having output variable as well as input variable, what is it? If your historical data is having output variable and input variable, so output, as I told, it is indicated with the help of Y, and this is nothing but X1, X2, and so on. Okay, if your historical data is having output and input variable, now what you do is you will randomly split the data. So if your historical data is having input and output variables, what you do further in supervised learning, you will randomly split the data. For suppose, imagine you have 10,000 observations or 10,000 records present in your historical data. So within that 10,000 records, you will randomly split this into, first of all, that is training data set. So in training data set, what happens? So I have totally, in my example, I got historical data or the data from the customer, which is having 10,000 observations. I got data with 10,000 observations. So within those 10,000 observations, I will randomly split the data. Maybe I will take 80%. I will randomly split the data into training data set in order to train the model. So suppose I have 10,000 observations and I'm randomly splitting this 10,000 observations and I want to take 80%, which means 8,000 observations into the training data set. So I want to take 80% of my records or observations present in my historical data. I want to take it into training data set. So this training data set now contains maybe 8,000 records. And now after that, what you do? After that, I will build a model. Based on this training data set, I will build a model. What is present and we will see. So I will build a model. How do I build a model? Here, building a model means we are learning the relationship between output variable and input variable. So what I'm telling here you have historical data, which is having number of records that I got from my customer. And my historical data is having output variable and input variable. Now I'm going to split my data into a training data set randomly, that is random sampling. So I've already told this when we are talking about inferential statistics, there are different sampling technique presents. So one that we have is SRS, simple random sampling. So we are randomly splitting the data into training data set. So suppose I want to take 80%. Why we are taking this into training data set? Because I want to build a model. What do you mean by building a model? What do you mean by building a model? So I want to build a model. Here, building a model means I'm understanding the relationship between output variable and input variables. I'm going to understand the relationship between output variable and input variable. And then the machine learning algorithm usually captures the relationship between output and input variable. Here you have machine learning. If you observe, this machine learning will understand the relationship between output and input variable using a math equation, which is mathematical equation. So using a math equation, you will understand the relationship with this mathematical equation. Okay, so up to here, you may have understood. Let us discuss again one more time. So there are two namings that you have to understand first. One is supervised learning and second one is unsupervised learning. In supervised learning, first of all, you have like a different steps involved. So you have training and validation here. So if you are receiving data from your customer, which is historical data, you want to randomly split the data and you want to take few of the data into training data set. Why you want to take it into training data set? Because you want to build a model. So building a model here means you are understanding the relationship between output and input variable with the help of a machine learning algorithm. With the help of machine learning algorithm, I am understanding the relationship between output and input variable with the help of a math equation. And then what? Once you capture the patterns, what you do is when you have 10,000 observations, as I've taken in the previous example, so 80% goes into training data set. 80% goes into training data set. And after that, you have taken it into training and you trained your model, and the model has captured the relationship in the data using a math equation. So out of 10,000 observations, I've taken 80% into training data set and I've trained my model, and the model has captured the patterns or the relationships in the data using a math equation. But then the other 20%, of the data that we have set aside is called as validation data. The other 20% that I've set aside is called as validation data. That is nothing but training and validation. So it's called as validation data. Now you take that 20% and apply the math equation on this validation data. So let's see what is present here. So there is a validation data set. The remaining 20% goes here, which is validation data. Now here we will apply that mathematical equation on this validation data set. We get to know how good or how bad the model is, that we will give you a model validation outcome. So it will make the predictions and validations, and it will give you the outcome, which is model validation outcome. So we are having 10,000 observations as I've taken in the previous example. I'm taking 80% into the training data set to train the model. And based on the mathematical equation, my machine learning algorithm is understanding the patterns or the relationship. And then the remaining 20% of the data that I've set aside is called as validation data. Now I'm taking that into validation data set and I'm applying the mathematical equation on my validation data. Now what I understand, I will get to know whether my model, how good or how bad my model is, that I will get some model validation outcome. So here, model is not about training your data and building a model. It also includes validating the model that you have built on your validation data. So you get to know how good or how bad your model is. Now, once you are satisfied with the result, on the validation data, also if your machine learning algorithm is giving you the good results, which means out of 10,000 records, I got 8,000 into training. I've taken 8,000 into training and then 2,000 as the validation data for validation, which is called as validation data. So this is how, if we are getting in the prediction outcome or the model validation outcome, good accuracy, it is giving good results, then I can understand, I can use this data on my future data also. So we take only inputs in validation data. You have to understand one thing, in this validation data, you will take only inputs. After that, we will get the predicted value after prediction and validation. We will take only inputs in validation data, and after applying this mathematical equation, we will get the predicted value, which is after prediction and validation. So it will compare the predicted values with the actual values. What happens here? It will compare the predicted values. It will compare the predicted values with the actual values. So here, for suppose, this is 80%, this is 20%. This is 80 and this is 20. Now, I got, after completion of all these things, I got accuracy of 95%, maybe 90%. I got accuracy of 90%. Now here what happens? It will make the comparison between what are the predicted values versus what are the actual values. It will make the comparison. So these 2,000 observations, how many are them? How many out of them are having the same predicted and same actual values? Based on that, we will get the accuracy. So what happens here after the prediction and validation, how you are getting this model validation outcome? Here the predicted values are compared with the actual values. Based on how many matchings are there, you will get the accuracy. Suppose I got 90% accuracy. Then what we do? We use the mathematical equation on the new data or future data. And then we will get again our predicted outcome. So this is how the supervised learning works. So here, how I get the accuracy here? By making the comparison between the predicted versus actual values. And after getting good accuracy results, I will use the math equation that I got here on the new data or on the future data. And I will get there also the predictions outcomes. Now let's see what is present next. So here if you see, predictions on the new data, which is also called as test data. And also remember one thing, this validation data is also called as development data. What is it? This validation data is also called as development data. So new data is nothing but test data. So if you have huge amount of data, like millions, trillions of rows are there, then what you do is, out of all the historical data which is having huge amount, you will take 98% into training and 1% for validation if you have huge amount of data. So we will talk about this further in detail, but just understand for now the concept. Otherwise, if the data is normal, which is not having most, it is not very large, then what you do is you will take 60% into training and 20% into validation, and the other 20% for the new data, which is test data. You will take 60% into training, 20% into validation, and 20% for test data. What is this historical data? You will have one is training data, second one is validation data, which is also called as development data, and the third one is test data, which is new data. So it will be like this, whatever you are taking into the training data set and validation data set. So originally, by default, what you do is in your data, out of 100%, you will take 80% into training and 20% into validation. So this is how it will work. So if we will give inputs and then we will get the outputs. You will see it here in this sheet here. So this is the new data, and after that, you will use the mathematical equation that you got, and you will just predict the outcomes, which is nothing but predicted outcome. So here, what happens? Here we will have the inputs and we will get the output. How? Based on the process that is happening in between, called as machine learning. What is it? Here we are giving the inputs and we will get the predicted outcome or output using a machine learning algorithm or a machine learning. This is how the supervised learning is working. So before going into the clustering or clustering algorithms, we have to understand two namings present, which is supervised and unsupervised learning. So coming to the supervised learning, here you have a concept called as training and validation. So out of all the historical data that you got from your customer, you will just randomly split your data into training data set and validation data. Validation data is also called as development data. So why do you take it into training data? Because you want to train your model. How you train your model? By using machine learning algorithms. So what does machine learning algorithms do? It will find out the relationship between output variable and input variables. And it will understand the patterns. How? Using a mathematical equation. Now, the rest of the 20% that you have set aside is taken as the validation data set. Validation data is also called as development data. Now, what you do, you will apply the mathematical equation that you got on this validation data, and after prediction and validation, you will get the modal validation outcome. So after prediction and validation, what happens here? So it will compare the predicted values with the actual values. Based on that, it will give you the accuracy. If your accuracy is very good, then you will move on to applying the mathematical equation on the new data, which is also called as test data. So here new data is there, you are applying the mathematical equation and you are predicting the results, then you will get the predicted outcome. So what is this supervised learning here? You will give the inputs and you will get the outputs using a process in between called as machine learning. So in here, you have to understand, in supervised learning, in historical data, you will have your output variable and also you will have your input variable. Okay, this is about supervised learning. Let's see what is present next. So the next one we are about to discuss is unsupervised learning. Okay, so unsupervised learning algorithm. Okay, here you have again the flow present. What is this flow? So for suppose, when coming to this unsupervised learning algorithm, again, we will take your historical data. Before we have discussed about the historical data, just like that, we will take again here the historical data. Okay, example, there is a bank present. You can take any of the bank, okay? So you have an example, I will take it here as a bank. And if the bank is having maybe out of all the countries, it is having overall 50 million customers. Okay. So if I am having the data set or historical data regarding a bank which is having about 50 million customers data, which is nothing but our historical data. So here you have again the data, but here you don't have any output variable. You will have all the inputs only, x1, x2, x3, and so on. So 50 million records, so on. These are 50 million. Okay, now what happens? Now, here we are not predicting any value. Here no prediction happens. For suppose, if I want to purchase any mobile, for suppose iPhone, I want to purchase an iPhone 14 Pro Max or something. So if I am using this bank credit card, I will get a special 20% discount. So I have an example like here, there is a bank and it is having out of all different countries comparing, I have 50 million customers, that bank is having 15 million customers. So here in this historical data of unsupervised learning, we will not have any output variable. Only input variables are present. Now, what is my requirement here is, if a customer is purchasing, who is belonging to this bank, is purchasing an iPhone 14 Pro, I will give an extra 20% discount if I use this bank credit card. So I want to do this promotion for all the 50 million customers present. So I have totally 50 million customers for my bank. So I want to do this promotion for all the different customers. So what should I do? Should I send an email to all the customers, all the 50 million customers? If I send an email, so there will be a lot of different scenarios here, like server cost is there, all of those things are present. And also, you have to understand the concept like you have to save your customers. You're not predicting here anything. Here, there is no case like prediction. So, what is happening here is you take your data here, which is the historical data. Any data is fine. You will take your data here and you will apply your machine learning algorithm. And here, there is no prediction happening. We are not predicting anything. So, what we are doing then? So, we will take a few customers. Here in the historical data, there are 50 million customers in our example. We will take few of these customers. And what we will do, we will just create groups for those customers. So what are these groups regarding? For suppose I have a group A. So these group belongs to the customers who are maybe students. So these customers group that have created group A, maybe they are students. I will create another group. Maybe these customers are very rich. These are middle class. So I have a lot of different groups or clusters created in out of all 50 million customers. I've created some. Now, the requirement here is we have like I want to give 20% discount on purchasing iPhone for these customers. So these may be suitable for only one type of customers. So students may not be interested in that. And middle class people don't want to buy an iPhone. So maybe the requirement that I have giving 20% discount may be useful to this group of customers. Maybe I will imagine that. I am not predicting anything in this scenario. I'm just understanding which cluster or which members require this promotion. Okay, so there is no prediction happening and you don't even know what is your output variable in this historical data. So I mean, here you are taking the data, applying the machine learning algorithms in which you will get the rules and patterns. Here you can see. So applying the machine learning algorithms, here you will get the rules and patterns. We use these rules and patterns to understand or make predictions on the new data. So what is new data? We will see what is present next. So here, prediction, we are predicting on new data. So new data, using those rules and patterns, we will make the prediction and you will get the predicted outcome. This is what happens in unsupervised learning. Here you are taking the data, which is new data is there, and we are applying the machine learning algorithm. Historical data is there, applying the machine learning algorithm, understanding the rules and patterns. Using these rules and patterns, we will predict on new data and get the predicted outcome. So whenever you have a new customer, you will just get this customer information, pass it on to the machine learning algorithm, which is already having the rules and patterns. And we can see whether that new customer will get into segment A or cluster A, segment B or cluster B, or segment C, and so on. So that information is nothing but the predicted outcome. What is it? As I have divided some groups in my particular historical data, if I got a new customer, if I have a new customer for my bank. So I will understand that new customer falls into which segment. Is it segment A, segment B, or segment C? I will understand that how based on the rules and patterns that I've got from machine learning algorithm. Based on the rules and patterns that I've got from machine learning algorithm, I'll apply those rules and patterns on the new data and I will predict my output. This is nothing but unsupervised learning. And in here, you have to understand one thing. We are not predicting anything. And also here, the output variable is not known in the historical data. So here you have all the customers in historical data. What is it? Okay. So here in the historical data, as we have taken 50 million customers, there are different types of customers. So this is nothing but heterogeneous. We can call it as heterogeneous, which means different types of people, different types of customers. And after that, the moment I perform clustering, you will get some related records like group A, group B, group C, related groups or related records or related clusters, whatever you can call it. So these related people will be in cluster A, cluster B, and cluster C. These clusters are always homogeneous. Why? Because these are related. So only the related records are grouped into one type of cluster, one type of segment, whatever that you want, you can call it. So related people will be here. This type of data set is called as homogeneous. And here there are different types of customers. So this is nothing but heterogeneous. Okay, so this is how you have to understand about the supervised and unsupervised learning. What did we understand about supervised and unsupervised learning? So what happened in supervised? In supervised learning, we have, for suppose 100% of data, which is historical data, in which I have an output variable as well as an input variable. I have output as well as I have input. Out of 100%, I will take 80% of my data to the training data set. After that, what happens in training data set? I will train my model using machine learning algorithm. Why am I going to train the model? Because I want to understand the relationship between output variable and input variable. How? By using a mathematical equation. After getting the mathematical equation, I have the rest of the 20% data. I will take it into validation data set, which is also called as development data. I will apply this mathematical equation, and after prediction, I will get the predicted outcome. So here what happens? Here the predicted value will be compared with the actual value and I will get the accuracy. Based on that accuracy, if the accuracy is good, I will use the mathematical equation on the new data. That is what is supervised learning. And unsupervised learning, what happens here? I have historical data present within which I don't have any output variable. And here I'm not predicting anything. I'm just applying machine learning on my historical data and I'm understanding the rules and patterns. Based on the rules and patterns, I will just understand whether the new data is entering into which type of cluster. That is called as predicted outcome. This is unsupervised learning. So let's see the differences in simple manner. Let's see the differences between unsupervised learning and supervised learning. So here you have two different types that you have understood. One is supervised and second one is unsupervised. So what you have understood? So in supervised learning, the output variable is known. You already know the output variable. In unsupervised learning, the output variable is not known. This is one difference. So the output variable is known in the historical data when it comes to supervised learning, but the output variable is not known when it comes to unsupervised learning. And then what? In the historical data, you have input and output. In this, you have only output. And the supervised learning is also called as predictive modeling. This supervised learning is also called as predictive modeling. And this unsupervised learning, it is also called as descriptive modeling. So prediction happens in supervised learning. So this is called as predictive modeling, and unsupervised learning is called as descriptive modeling. So now, as we have understood the differences between supervised and unsupervised, we will see what is present next. Let me clear this. The next one that we have is cluster 101. The next one that we have is cluster 101. We will see what is present. So here, Cluster analysis is also called as data segmentation. Usually, in a marketing standpoint, people call this cluster analysis as segmentation. So cluster analysis is also called as data segmentation. In a marketing standpoint, this is called as segmentation, and it is an exploratory method. It is an exploratory method. So here, clustering identifies homogeneous group of records. For suppose, we will take an example. For suppose you have emails. You have emails, right? So in your emails, you have different groups again. Like what are the social mails? And what are the promotion emails? And what are spam? So there are different groups present in emails itself. So all belonging to promotion comes to here, and what are unnecessary comes to spam. This is how we will just group related records, which is homogeneous group of records, which is called as clustering. So clustering will identifies homogeneous group of records, which means similar type of records. Now what? So within the clusters, so we will see here, similar items should be grouped together into homogeneous groups. What is it? If you see here, what are all the similar records present, that will be grouped into one cluster, and that will be grouped into another cluster and another cluster. There are different clusters present. Now, if you see here, similar items will be present in one cluster, which is called as homogeneous. Now, within that particular cluster, the similarity should be more, which means the distance between the items or records should be very less. If you see here, there is one cluster which is having the data points which are densely present in this particular cluster. And here also, I have different records which are densely present in this particular cluster. And here also same. So I have different records. Now, what is happening here? In every cluster, the data will be always homogeneous. Why? Because the similar records will be grouped together into a common cluster. And always the similarity should be more between the clusters. So here you have to understand. So when we are measuring the similarity between the data points or records within the cluster, this is called as within the cluster similarity. This is called as within the cluster similarity. Here also, within the cluster similarity. Here also. Okay, always the similarity between the data points or records within the cluster will be always, so see here, within the group, similarity is always high, and also that is the distance between the records or items will be less within the cluster. So within the cluster, the distance between the records or items is less and the similarity is more. That is nothing but within the cluster. So what happens when we compare one cluster with another cluster, which means one group with another group, or one record in one cluster with another cluster? When we make such type of comparison, that is not within the cluster. That is not called that within the cluster. That is called between cluster. That we can call it as between cluster. So we are making or understanding the similarity between this data point present in cluster A to this data point or this data point. So we are making comparisons between different clusters. That is nothing but between cluster. If we are making comparison or similarity between the data points in the same cluster, that is within the cluster. So always you have to remember the similarity between the data points or records or items within the cluster will be always high. And the similarity between different clusters will be always less. And here, within the cluster, the distance will be always less. And here, between different clusters, the distance will be always high. So dissimilar items which are not similar, that will be called as heterogeneous groups, which means when we compare this group to this group, these are not having similarity. That is why they are present in different groups. That is called as heterogeneity, which is heterogeneous. Okay, fine. Now what? So between the groups, the dissimilarity should be more. Here, you have to understand. So similarity will be less, which means the dissimilarity is more. And the distance will be always more. So this is low interclass similarity, which is distinctive between clusters. This is high intraclass similarity, that is cohesive within the clusters. So you have to remember these namings. So what is this one? Cluster analysis is also called as segmentation or data segmentation, and it is an exploratory method. And clustering is nothing but it will identify similar group of records or homogeneous group of records, and it will create some random clusters. and the data points which are similar items present are grouped together inside a cluster, the similarity will be always more. So within the cluster, the similarity is always more. So within the cluster, the similarity is always more, and the distance between the items or records is always less within the cluster. The distance between the records or items are always less within the cluster. When we make the comparison or understand the dissimilarity between one different group and one different group, which is nothing but heterogeneity, heterogeneous items or heterogeneous groups. Now, in this case, the dissimilarity will be more. In this case, the dissimilarity is more, and the distance between two different clusters or records in two different clusters will be always again high. So this is called as high interclass similarity, and this is called as low interclass similarity. So this is about clustering 101. Now let's see what is present in the next slide. The next one that we have, clustering when we have a single variable. When you are having a single variable, okay, if we have a single variable like maybe I can take age or I can take income, and we are asked to perform clustering. Okay, fine. Okay, I'll give break for 10 minutes. Everybody just go for break and come. We will talk about this. Everybody go for 10-minute break and come back. We will start talking from here onwards. I'll be on mute. Okay, everybody, let's continue with the session. So we have discussed about the difference between supervised and unsupervised learning, and we have started talking about clustering. So here, when we have a single variable, for suppose imagine we have a column like maybe age or income, anything is fine. So for suppose you have a column, maybe age or income. So for that particular column, which is having a single variable, I want to do the clustering. So we are asked to perform clustering for this column. Now you can simply just create a box plot for this column. So let's see what is present in the slide. So see, there is an age column present. So for this age column, I'm asked to perform the clustering for this column. So simply what we do is we will create a box plot. So based on this box plot, how can we do the clustering? Maybe I will say the outliers which are present from here, this particular data, I will just take it as one cluster. And within the box, whatever the data points are present, I will take it as second cluster. And from here to the max, I will take it as third cluster. So with the help of a box plot for a single variable, I can do the clustering. Okay, fine. So here we have totally 3 clusters. Now, if my client asks me that he wants to have a lot of more segments, lot of more segments, then what to do? So we can divide, like I will take this as 1. Maybe I will just take from here to here as second, and this is third, and this is fourth. I can take whatever that I want. So you can further divide it into more clusters if you want. So here, let me see what is present in the slide first. So, okay, fine. So when we are having a single variable, how to do the clustering? With the help of a box plot. With the help of a box plot. So if you want to divide it into 10 clusters, what you do is, you will look at the range of age column. Range, you already know, range is nothing but maximum minus minimum value. And what is the range? Based on that, I will divide it into 10 clusters or 10 segments. This is how we will do the clustering or segmentation when we have a single variable. When we have a single variable. If I do this, I will divide the data into 10 different segments or 10 different clusters. So if you have a single variable, if you are asked to perform the clustering, you can simply plot a box plot. What is it? If you are having a single variable, which is nothing but a single column, and if you are asked to perform the clustering, you can simply plot a box plot. Now next, the next one that we have, when you have 2 variables. When you have 2 variables, for suppose, okay, here you have a chart present, see here. So here, when you have 2 variables, x and y. So here is x and here is y. You have 2 variables, x and y. And for these 2 variables, you are asked to do the clustering. So now what you have to do, you can simply plot a scatter plot. You can simply plot a scatter plot. So here, we are doing a scatter plot between the temperature of x variable, and maybe here the light intensity. So when you are plotting a scatter plot here, probably I got 3 segments, 3 different segments. Like this red giants are one segment, which is one cluster, and this is belonging to another cluster, and this is belonging to another cluster, which means all the similar records. Here you can see white dwarfs. All the similar type of records are grouped together into different segments called as clusters. So when we are creating a scatter plot, when we have 2 variables, we can do the clustering like this based on the similar type. So let's see here in the example, it will be shown clearly. So see, these are the 3 different types of segments that I got in my scatter plot. The moment I have a scatter plot, you can determine the clusters, which is the secondary purpose of a scatter plot. You already know what is the primary purpose of a scatter plot. Scatter plot primary purpose is to understand the relationship, which is the correlation between 2 numeric variables, 2 continuous variables. And then in that also, the first one that we have is strength. How strong is the relationship between the 2 variables? And what is the direction, whether it is positive or negative, and whether they are linear or non-linear. This is the primary purpose of a scatter plot. And coming to the secondary purpose, it is used to identify the outliers as well as clusters, as well as the clusters. So the moment I have a scatter plot, I can determine the clusters, which is the secondary purpose of a scatter plot. So in most of the scenarios, you may not have a single variable. You may not have 2 variables. You may see more than 2 variables. So neither you can use box plot or scatter plot in order to perform clustering. So for that, you have to work or you have to use another mechanism called as multivariate distance. What is this? So clustering, you already know the similar type or homogeneous types of records. You are grouping them together into a single cluster. If you are having a single variable, you will plot a box plot. If you are having two variables, you can understand the clustering with the help of a scatter plot. But now in most of the scenarios, you won't have a single variable. You won't have two variables. You will see more than two variables. So you can neither plot the box plot or a scatter plot. Then you have to understand one more mechanism called as multivariate distance. One more mechanism which is called as multivariate distance. When we will use this mechanism when we have more than two variables. So when we are not having one, when we are not having two, when we have more than two variables, you will go for multivariate distance. Okay, we will see what is there. So scatter plot, see here. Clustering, when there are more than two variables, you will go for multivariate distance. So here, understand. So when you are computing the distance, so you have to remember 2 points. One is you may need to calculate. So here, see. The distance between two records means what? Means what? So when we are computing the distance, you have to understand 2 points. First one is you want to calculate the distance between records. Distance between records, or you might want to compute the distance between record and a group. Like what? For suppose I have two clusters. I have two clusters. Now I want to compute the distance between the data point in one cluster to the data point in the same cluster between the records. This is computing the distance between the records. So maybe between two people, between two movies, between two products, I am making the comparison. I am computing the distance. That is the first thing, which is computing the distance between records. And the second one that we have is computing the distance between groups or clusters. You can call whatever you want. Computing the distance between record and a group or a group and a group. So these are the things that you have to understand. So record and a group, which means the record present in one group with other group, what is the distance? Or between two groups, what is the distance? This is how we will compute the distance when we go for multivariate distance. So when we are going for this multivariate distance, when we have more than two variables present. Okay, so here, always remember clustering is nothing but here we are grouping together the similar records. When we have a single variable, we will go for a box plot. When we are having two variables, we will go for a scatter plot. If we are having more than two variables, then you will go for multivariate distance. Here we are computing the distance between maybe records, maybe record and a group, and between two groups. Between two groups. So here, here if you see this example. So here, always remember, when we are building a predictive model, always that may not be your business problem. Prediction is not always that is not the case. That is your business problem. Certain business problems may be also related to segments, which is nothing but clustering. So in such scenario, we will go for this clustering, like maybe using a box plot, maybe using a scatter plot or multivariate distance. So predictive modeling, as I told, that comes under supervised. When we are talking about unsupervised, we have clustering happening. Okay, so here's an example present. There are various customers. Maybe here there are 12 customers present. What is it? There is an example present here. Out of there are totally 12 customers. There are totally 12 customers, and different variables are also present. So, what is the gender of this particular customer? Whether he wears glasses or not. If he is wearing the glasses, that is Y, which is S. If he is not using glasses, it is N, which is no. And if he's having a mustache, if he's smiling, if he's wearing a hat, based on that, I have an example data set. Now, what I want to do is, I want to group related records together. What is it? I want to group related records together. What do you mean by related records? Which are similar to each other. Related records, I want to group them together. Okay. Now what I have to do? I have to pay attention and understand which two customers are similar. For suppose, here see the customer 1 is similar with customer 7. If you see here, 1 and 7, two different customers are there. Both are males. What is it? Two different customers are there. Okay, so both are males. Both are males. So we are comparing the two records, which is 1 and 7. Both are males. Both are wearing glasses. They don't have a mustache, and both are smiling, and they don't wear a hat. So all the records or all the columns for these two customers are almost same, which means these are similar records or related records. Now what happens here? A group will be created for these two customers 1 and 7. So here see in this, it will be shown clearly. So 1 and 7 customers are almost similar together because all the records are having similar values. Now these two are grouped together, which is shown on the left hand side. Now just like that, understand whether any other two customers are related to each other. If you see here another example provided, 10 and 12 are also similar. Both are females, no glasses, no mustache, not smiling, and not wearing a hat. Both are similar. Now what happens? These two records are again grouped together. These two records in yellow color on the left hand side, that shows these are belonging to similar group. That is nothing but an example provided there, which is showing different customers. Okay, fine. Now what? As customer 1 and 7 are similar, they are present in one group, and the customers, the last two customers 10 and 12 are similar, we can group together into a similar segment or similar group, which is a cluster. So you don't see, so always remember, as there are multiple columns present, you always have to consider all the columns. You can't say like, whoever the customers are males, I will group them into one group. Or whoever the customers are females, I want to group them as another group. I can't do that. I have to consider all the given inputs. All the given inputs I have to consider. Based on that, whatever the records that are related, that will be grouped together, which is called as clustering or segmentation. Now, what is that? So you have to remember one more thing. Here, the next one that we have is hierarchical clustering. Hierarchical clustering. So there is an example provided here. Here, suppose you have a set 1. So here it is having 6 values. Here in this example, I have 6 values A, B, C, D, E, and F. Imagine these are 6 different universities. These are 6 different universities, and I need to cluster them. I need to create groups for them. How to create groups for them? See here. So here, first, you need to find the distance between each of them. Like what? What do you mean by each of them? Means you have to find out the distance between A to B, distance between A to C, distance between A to D, A to E, A to F. And also similarly, you also have to find from B to C, B to D, B to E, and B to F. So here you can see A to B, C, D, E, and F, and B to C, B to D. So this is nothing but distance matrix. We have to find out the distance between each and every data point, which is called as a distance matrix. So this word you have to remember. So there is a set present which is having 6 values. Within that 6 values, I want to do the clustering now. How to do the clustering? So I'm going to use the concept called as distance matrix, which is computing the distance between each and every record, each and every data point. Then you found that, okay, here it will be shown, see. Now what I have understood is the distance between this B, C, and D are less. I have understood like the distance I have figured out based on the distance that I have measured between the records. B and C and D and E are very close. You find the distance between the records. So this is very close. Then what happens? Automatically see here. See here, B, C, and D, E are grouped together. What did we do? First of all, we have found the distance between each and every record with each and every other record. Then I understood like the distance between B and C and D and E are very close. So they are clustered together, which I have got on the left-hand side as B, C, and D, E, which is the group of records which are similar together. Now what happens? Again, I will calculate the distance. Distance between what? A to BC, A to DE, A to F. And also BC to DE, BC to F, and so on. So this is how I will calculate for the next group. Then what happens? I have understood like the distance between DE and F are very close. Then they will be grouped together, which is DEF. And after that, what happened? So I will again find the distance between A to BC, A to DEF, BC to DEF. And after what I have understood, the distance between BC to DEF is very close. Then they will be combined as one group, which is A, BC, DEF. Then what happened? Again, I will calculate the distance. Then again, I will group them together. This is how we will do the hierarchical clustering when we have different values. Based on what? Based on the distance matrix. Based on distance matrix. So at step 0, if you understand there are different stages present, at each and every stage, at the first stage, every different value is considered as a separate cluster. So at step 0, each and every record is treated as one cluster. And finally, all the records are treated and combined as a single cluster, which is stepwise. So at step 1, you have 4 different clusters. At step 2, you have 3. At step 3, you have 2 clusters. And finally, at step 4, you have a single cluster. So this concept is called as agglomerative nesting or agglomerative clustering, which is AGNES. Agglomerative nesting. This is one type of hierarchical clustering algorithm present. So what is this? Here we will calculate or we will find out the clustering between different values based on distance matrix. And here at step 0, always every individual record is treated as an individual cluster. And at last, all the records are combined together as one cluster. This step process from step 0 to step 4 is called as agglomerative nesting. If we are doing it in reverse manner, from step 4 to step 0, then that is called as step 0, step 1, 2, 3, and 4. This is in reverse manner. Then that is called as divisive analysis. That is called as divisive analysis. So these are the 2 different types of hierarchical clustering present. If we are performing from step 0 to step 4, which is treating each and every record as an individual cluster, to combining them as a single cluster, that is called as agglomerated nesting. If it is in reverse manner, that is called as divisive nesting or divisive analysis. So these are some of the hierarchical clustering algorithms present. So we have again others also present, like what we will see. So hierarchical clustering is of 2 types, that is either agglomerative or divisive. So it begins with n records and find all the distances between records, and it will merge all the similar type of records or group of records until it forms a large group. What is agglomerative clustering? What is happening here? So here there are individual records present. So all the individual records according to the distance matrix, which means the distance between one record to the other record, based on that, I will group all the similar type of records into one large group. At last, what happens? All the records which are similar to each other will be grouped as a large group, which is called as agglomerative clustering or divisive clustering. If it is from step 0 to step 4, it is agglomerative. If it is in reverse manner, that is called as divisive. So these are the different hierarchical clustering algorithms present. So apart from them, you also have other algorithms. That is, first one we have is balanced, iterative, reducing, and clustering using hierarchies. And the next one is clustering using representatives and chameleon. So these are the other hierarchical clustering algorithms present. Okay, before understanding this agglomerative or divisive clustering, we have to understand the next important concept called as distance measures. Okay, so we will check it out what we have discussed up to now. Then we will move on to the distance measures. If not, we will forget everything. So in this module, we have started discussing about supervised learning. What is supervised learning and what is unsupervised learning? So we are understanding the differences between these different namings present, supervised and unsupervised learning. So what did we understand about supervised and unsupervised? In supervised, you will have an output variable. The output variable is known. In the historical data of supervised learning, you will have both input variables as well as output variables. But in validation data, we will take only inputs. And coming to the unsupervised learning, we don't have any output variable. This is not known. And supervised learning, we will mostly use it for predictions. It is called as predictive modeling. And unsupervised learning is called as descriptive modeling. This we have understood. Now coming to the clustering. So what happens here? All the homogeneous, which means the similar type of records, are grouped together under the concept called as clustering, which is also called as data segmentation. This is an exploratory methods. Okay, so always remember there are different clusters, and within the clusters, when we find the distance will be always less. And the similarity between the records within the cluster is always more. And when we are comparing between different clusters, then the dissimilarity is more and the distance is also more. This is what you have to understand. And how to do this clustering? When you are having a single variable, you will perform clustering using the box plot. Okay, you will perform the clustering using box plot. If you are having two variables, then you will go for scatter plot. And if you are having more than two, then you will go for multivariate distance. So what is multivariate distance? Within this, we will compute the distance between records, record and a group, and between different groups. In that, we have seen the examples of 12 different customers are present. Whoever are similar, we are grouping them together. And also there are set of records present. Out of those, whichever the distance is similar, using the distance matrix, we are grouping them together. If we are performing to step 0 to step 4, that is called as agglomerative nesting. If it is in the reverse manner, that is called divisive analysis. These two are the hierarchical clustering algorithms that we have seen. And apart from them, we have again balanced iterative reducing and clustering using hierarchies, and also clustering using representatives and chameleon. So before moving deep into this type of clustering, what is this doing? What are the different things that are present in this? Before talking about all those things, we will see, or we will talk about distance measures. So what is distance measures? So the next one that we have is distance properties or distance measures. So let us discuss about few of the distance properties present. Okay, so always one logic is very clear. What is that logic? So what is that logic is, if we have three different groups or three different clusters are there. So here within the cluster, all the data points are closely packed, like densely populated area. And second one is, okay, so what is it? Within every cluster, the data points are closely packed, and the similarity between the data points within a cluster is always high. And it is also called as the similarity called as within the cluster similarity. And the similarity will be high. And what is the next one? The similarity between different clusters will be always less, and the dissimilarity is more, and the distance is also more. This is called as between clusters. Okay, so the distance between two different clusters is called as between, and the distance between two individual records is called as within. These namings you have to remember. So for any clustering algorithms, this is how it works. This is very common for every clustering algorithm, whether it is hierarchical, agglomerative, anything. Any clustering algorithm, this is the common thing that is present. Fine. Now what? There are few other properties of distance which are present over here, which is there are two different data points. What are these two different data points? So what are these two different data points? So understand. So first of all, you have two data points. One is I and second one is J. So Dij is nothing but the distance between these two data points or records, which is I and J. This is nothing but Dij. Dij is always greater than 0. What is this? The first requirement is that when we travel, even from I to J or the J to A, there will be some distance present. It will not be equals to 0. It will never be 0. There is some distance present. That is nothing but the first property, which is the distance is always non-negative, which means it will be greater than 0. Okay, whether you are like moving in forward direction or in backward direction, you are traveling some distance. The distance is never 0. The distance between two data points should be always greater than 0. It can't be less than or equal to 0, which is the first distance property. Okay, this is the first distance property. Coming to the second property. The second property is that the distance from a specific data point, say that, so see here, this is DII, which means you are traveling from I data point to I itself. So the distance from a specific data point once again to the same data point will be always 0. What is the second distance property? The distance from one specific data point to the same data point will be always equal to 0. And then the symmetry. Coming to the symmetric property also has to be met, like we suppose the distance from I to j will be always equals to j to I. So the distance from office to my home will be equals to home to office. That is nothing but symmetry. Dij is equals to dji. The distance from I to j is always symmetrical from or symmetrical to the distance from j to I. That is the third property. And coming to the fourth one, there is one more property called as triangle inequality, which means, say we have a triangle. We have a triangle. This is I, this is j, and this is k. The distance between I and j is dij, djk, and dki, or you can call dik, anything is fine. So this is the distance. Now what? Distance between I and j, which is dij, plus distance between djk, which is j and k, which is djk, will be always greater than or equal to djk. It is not always less than. This is the triangle inequality. If we add the distance between two sides, it will be always greater than or equal to other third side. That is triangle inequality. You have learned all these things before. These are the distance related properties present. Let's see one more time what are these distance properties. So here, before moving on to the agglomerative or divisive clustering, we have to understand about the distance measures and distance properties. So here, if you have seen this example provided, there are two different data points present, I and j. So the first property is that the distance that is we are traveling from I to j, two different data points will be always greater than 0. We are traveling some distance, whether in forward direction or backward. The distance that we have traveled will be never equal to 0 or less than 0. That should be positive, which is non-negative. And the second property is the distance from a specific data point to the same data point will be always equals to 0. And also, when I am traveling from one point to another point, the distance is calculated. And then the reverse manner is also seen. That is called as symmetry. And when we go for the last property that we have, the triangle inequality, the distance between any two sides of a triangle will be always greater than or equal to the third side. It will be never less than the third side. These are the distance properties that are present. Okay, so we will see the use case if we have any use case provided here. So here is our use case present. Okay, so this is an example provided which talks about different universities. Here you can see. Here you can see there are different universities present like Brown University, Caltech, CMU, Columbia, etc. All these universities are present. And the second column that we have is SAT score, which is an entrance exam. You already know. So this is SAT scores of every university. What is the score that is accepted? And top 10. Top 10 is nothing but what percentage of the customers that are applying for the university are in top 10. What percentage of customers that are applying for the university in top 10, which is 89%, 100%, and so on. Now, acceptance ratio or accept. What is this one? Out of 100 applications that are applied for this particular university, how many are getting accepted? For suppose, imagine for Brown, the acceptance ratio is 22. So out of 100%, 22% are getting accepted. That is called as acceptance ratio. And the next one that we have is student faculty ratio. Then you have expenses in dollars and also the graduation rate. So what is the graduation rate? the percentage of students that are graduating. So out of 100 students that have joined in this particular Brown University, 94 are getting graduated. This is nothing but graduation rate. These are the various columns present in our example. Now, we have to cluster or segment these universities. We have to cluster these universities. How do we cluster? How can we perform clustering in this particular example? So see here. Okay. So we have to do the clustering or segmentation in this example. So before doing the clustering, what is the first thing that you have to do? You have to understand your business problem. You have to understand your business problem. The business problem might be that when students write SAT exam, there would be a provision to apply to the universities based on SAT score. What is it? When students write SAT exam, there would be given a provision to apply to the universities based on their scores. So when they want to apply, a bunch of universities will pop up and recommend them to apply for that university. So the moment someone writes the entrance exam, immediately the choice of other related universities should also show. That is our business problem. So when I'm searching for a specific university based on my SAT score, I should also get the recommended other universities which are related to this university. That is my business problem. As this is not based on prediction, we want to group the related records together. That is nothing but clustering or segmentation. So this business problem, we have to create a cluster or we have to create a group for the universities so that it will be easy for the students to apply for the other similar universities. That is our business problem, and that is what we have to do in this particular use case. Here, there is one more thing. As a dean, you want to know which are the universities which are very similar in nature based on the given attributes. So I start doing a competitive analysis with those universities which are similar to my university. Now, what shall we do is, we find the distance between each record. So how to do this? How to work on these business problems? So first of all, what I want to do is, I want to find out the distance between each record, which means Brown to Caltech, Brown to CMU, Brown to Columbia, Brown to Cornell, and so on. I want to find out the distance that we have seen before, the distance matrix. No, now we have to find the distance between all the records. Let's take the distance from Brown and Caltech here. So we have a lot of columns. We take the difference between each values. So here we will see that is present in the next slide properly. Here, distance between the records. So here imagine I is nothing but Brown University and J is nothing but Caltech University, which means between two records, we are calculating the distance. Now, what is it? Here? So see here, the Brown is having values. So what is this values? What are these values? Here, I is Brown University and J is Caltech. So Brown is having multiple columns. Like what? So this is nothing but the SAT score. And what else are present? The SAT score is there, and top 10 is there, top 10 and acceptance ratio, and also students faculty ratio, and also graduation rate. So there are multiple columns. So 6 columns are there totally. So 6 columns, I got values for 2 different universities. Now what is it? Now I have to find out the distance between the 2 records. How to find the distance between 2 records? So see. So you already learned this formula before. Maybe you have a data point like, okay, fine. Before talking about that, you have a simple example like 2 data points are there. One is having coordinates like x1, y1, and second one is x2, y2. Then how to calculate the distance between 2 data points? You already know this formula, that is y2 minus y1 whole square plus x2 minus x1 whole square. This particular formula is called as Euclidean distance. You may get confused when you see this word in RapidMiner Studio. So that you have to understand the concept first and then you will move on to the practical. So this particular formula is called as Euclidean distance. So just in the same manner, we have calculated the distance between these 2 records. One is Brown and Caltech. How is it? So this is xi1, which is 1310, which means what? 1310 minus xj1, which is 1415. 1415 whole square. Just like that, we have to do for every individual column. 89 minus 100 whole square plus 22 minus 25 whole square plus 30 minus 6 whole square plus 22,704 minus 63,575 whole square plus the last one 94 minus 81 whole square. For each and every record, we have to calculate this and we have to do the square root. That is how we will calculate the distance between two records. Okay. So this distance is called as Euclidean distance. This is called as Euclidean distance. See here, just like I've written before, this is calculated. And then what? And then what? I got a value here. When we calculate the distance using this Euclidean distance formula, this I got here, which is 40871.1391. So as we are having more number of columns like SAT and what is student faculty comes under unsupervised learning. You are having a lot of different columns. What are those columns? So what are the different universities present? And what are the SAT scores? And so here we have different columns present. What are the universities? What are the SAT scores? What are the student faculty ratio? What is acceptance ratio? What is graduation rate? All these columns are present, which are input variables. We don't have any output variable. So this comes under unsupervised learning. This comes under unsupervised learning. And here we are working on a type of distance called as Euclidean distance. Euclidean distance is calculated for different records like this. So when we do this or calculate this distance between the two records, which is Brown and Caltech University, I got the value, which is 40871.1391. We got very big number. Why did I get such a huge number? What is the reason? What may be the reason? Because we have here very big numbers for columns like this one, which is expenses. So there is a column called as expenses in my dataset example. That expenses is very huge. This is in dollars. I told this is in dollars. So because of this huge value, I got the output also very huge. This is a 5-digit number. If we just convert this dollars into rupees, if I convert this into rupees and perform this distance, then it will be even bigger. So why am I getting this huge value? Because the scale is larger for this particular column, which is expenses column. Because of huge scale, I got a huge value. So I can say that because of this expenses, I had a huge impact on the overall distance. Because of this expenses column, I had a very huge impact on this particular column called, this particular value, which is nothing but the Euclidean distance between the two records. Okay, fine. So for suppose, if you see all the other values, so these are the values which are very less. These are the values which are very less. So I can say, because the scale is very less, this is having very less influence on what? On the overall distance. On overall distance. So based on the scalings of all the other values, we have the output value, which is the distance. So because of the huge value of expenses, I have huge impact on the overall distance. Because of very less values of this particular column, this is having very less influence on my overall distance. So this overall distance value will be based on all the columns. All the columns is having equal priority to get this output value, which is overall distance. So what we have to do is, we have to perform data scaling. You already know this concept, which we have seen yesterday. So you have to perform data scaling, which is also called as feature scaling, which can be also called as maybe feature shrinking or data shrinking. There are multiple names present. You have to perform data scaling. Why you have to perform? So in order to perform that, you already learned different techniques present. What are those? One is normalization, which is normalize, which is also called as min-max scalar method or range method. And second one is standardization. And the third one is robot scaling. You can use any of these three techniques present in the data scaling in order to convert this huge data into normalized data. Okay, so let's look at the standardization. Standardizing the data for every column that you have so that your mean and standard deviation you have to calculate. Let's see what is present in the next slide. So what we are doing here, we are finding out the distance between the records. Before we have seen, if you are having multiple input variables, what we have observed everybody, if you are having one variable, in order to do the clustering, you can go for a box plot. If you are having two variables, then you can go for a scatter plot. If you are having more than two variables, you have to go for the concept or a particular mechanism called as multivariate distance. In that multivariate distance, we already seen we are computing the distance between records, between record or a group, between the groups. First, we are discussing about calculating the distance between the records. So here, there are two records that we have taken. One is Brown and second one is Caltech. And I am finding out the distance between two records based on Euclidean distance. And here, the value or output of overall distance that I got is based on all the column values. Whichever values are very large, that is having huge impact on the overall distance. Whichever the values are very less, that is having less influence on the overall distance. Now, in order to just make it equal for all the columns, I have to standardize the data. You already we have already seen standardization yesterday. We will see in detail today how to do it on original data. So see here. So standardizing the data. Standardization formula you already learned, x minus mean by standard deviation. When we standardize the data, after standardization, the mean will be always equals to 0 and the standard deviation will be always become 1. That is present in a specific range, which means a scale. So now see. So after standardizing the data, which means what we are doing here. After standardizing the data means what we are doing here. Here, we are performing this particular standardization on every record, which means what? For this record, how to standardize this? 1310 minus, I have to calculate mean for this particular column. That particular mean divided by the standard deviation. That I have to perform for all the records. When we do this to both Brown and Caltech University, every value will be... So every value will be now standardized like this. So 1310, after applying this formula, this converted into 0.40199. This has to be done for every value present in every record. So Brown, we are just comparing the distance between these two records. So we will talk about only these two now. So when we do this to both of this Brown and Caltech University for every value, this will be converted into standardized value. Once you have those standardized value, now you will calculate the same Euclidean distance. When you do this after standardization again, you will calculate the concept which we have discussed before, that is Euclidean distance. So you already know the formula, that is square root of y2 minus y1 whole square plus x2 minus x1 whole square. That you have to again do for this particular standardized values. Okay, so we will see what is the output. So after performing the standardization, okay, after performing the Euclidean distance between the standardized value, I got now the output that is 3.56, which is very less. So even the 5 big digit number expenses are there in my data. With the help of the standardized values, I have converted the overall distance to be very normal. 3.56 is normal. This is not very huge data, just like this. So that is where we have to, that is how we have to calculate the distance. That is how we have to calculate the distance. So what did we do, everybody? Here, we have a use case provided, which is having multiple input values. And here there is no output variable is present. So it comes under unsupervised learning. So in unsupervised learning, we have started discussing about the segmentation or clustering concept. Here I have to create clusters for universities which are related to each other. So in order to first perform clustering, you have to find out the distance matrix. So here we are finding out, first of all, the distance between the records. In order to find out that, we have a concept called as Euclidean distance. If we are having huge values in our columns, that may impact our overall distance. In order to not understand that impact, huge impact, less impact on the overall distance, we can just go for the concept called as standardization. So standardizing the values, I got very minimum overall distance. This is how we will calculate the distance. Now what we do? Apart from the Euclidean distance, you also have a lot of other distances also. We will see what is present next. So distance metrics for the continuous values. What is distance metrics for continuous values? So whatever the values that we have seen before, what is this? See here. So in this particular use case that we have seen, so this every value, the SAT code stopped in, all these values are numerical. All these values that we are calculating are numerical. So that is how we are performing the normalization. Like what? Here you have SAT column, which is a numerical column. So I will just take every individual record and perform standardization, which is x minus mean of x divided by standard deviation of x. By using this formula, I will calculate the standardized values for every other record. Why am I doing this? Because the columns are numerical, which is continuous columns. So when they are continuous, in order to calculate the distance, I can go for the concept called as Euclidean distance. So this is the most used one. Apart from Euclidean, you have few others as well. Let's see what are those. So distance metrics for continuous data. So you already know continuous data. This is how we will calculate the distance. And here, all the values are numerical. So this is how we will calculate distance for numerical values. And the distance is called as Euclidean distance. Apart from Euclidean distance, you also have some other called as Manhattan distance. Some other type of distance is called as Manhattan distance. Okay. So here, you have to remember one thing. So Euclidean distance is there. Euclidean distance is there. That is called as L2 norm. This is called as L2 norm because we are squaring the values. This Euclidean distance is also called as crow fly distance. So what is crow fly? For suppose imagine there are two data points, this data point and this data point. So there may be multiple ways. For suppose the proper way is this one. I have to go this way. I have to go straight. I have to go right. Again, I have to go left. Something like that. But the crow flight distance, the Euclidean distance is, I will calculate like this. This is called as L2 norm, which is also called as crow flight distance. Why? Because we are squaring all the values. So all the squares, we are performing the square root. That is why this is called as L2 norm. Okay. So if a crow is flying from one data point to another data point in this way, this is Euclidean distance. Whereas there is one more thing, which is Manhattan distance. This is called as city block distance. So it will go in a proper way, in an organized way. This is called as Manhattan distance, which is also called as L1 norm. L1 norm. Why? Because we don't have a square here, only power 1 is present. So see here. This is L1 norm. So we will take the modulus of all the values. That is why it is called as L1 norm. Apart from Euclidean distance and Manhattan distance, we also have one more thing which is present here. That is, okay, this is Euclidean distance, which is crow flight, and which is the next one, which is Minkowski distance, which is generalized distance. And the last one that we have is statistical distance, which is also called as Mahalanobis distance. So here, S is nothing but covariance matrix. You already know covariance, which we have seen in the mind map. It is somewhat different from correlation in scatter plot. In covariance, we don't talk about both direction and strength. So we have talked about this before. Now, if the values are not numerical, if the values or the columns that you have are not numerical, if they are in categorical, when you have categorical or binary data, how to calculate the distance? Okay, we have calculated distance in multiple ways when it is a numerical variable. What is it? when the columns or variables are numerical, then you can calculate the distance between records in multiple ways. This is what everybody understands. We are calculating the distance between records, not record or a group or between groups. We are calculating the distance between records. How we are calculating for numerical? Based on Euclidean distance or Manhattan or Mahalanobis or statistical. Any one of it we will use. But the mostly used one is Euclidean. But if we are not having any numerical columns, I want to calculate the distance for categorical, which is binary data. Then what you have to do? We will see. So see here. Here you have 2 by 2 table. You have 2 by 2 table, which is having 3 columns, which means 3 variants are there. What are the 3 variants present here? Here, one is whether these persons are graduates or not, whether they are alcoholic or he is vice president or not. These are the 3 variants present. Now we have to find out which 2 persons are similar, which is nothing but clustering, which is segmentation or something. This is not prediction. This is unsupervised. There is no output variable. So here I want to understand which of the 2 records are similar. Okay, now we will see what happens here. So what happened here? Observe what happened. So in this particular first table, when I just observe the similarity between A and B, so these 2 are not same. These 2 are same. These 2 are again not same. So these are not similar. When I compare A and C, so this is not same. Y and this is not same. Y and not same. This is same. This is also not similar records. When I compare the next one, which is maybe B and C, when I make the comparison between B and C, these 2 are same. These 2 are not same. These 2 are not same. Then what I have to make a comparison between? So see here. Now, I want to see whether A and C are similar or not, or how much similar. I want to measure the distance. How to calculate it? See here. So here, I have plotted or I have populated a table here. What is this? Once we populate the table, you can generate and calculate the distance. How can I calculate it? So see here. So A is present and C is present. And there are 2 variants, whether N, like a S or no. Okay. First, we will see. I am comparing between A and C. So yn, wherever yn is there, so see here, yn is present, that is 1. And then what? There is one more yn. So 1 plus 1, that will be 2. And y and y. So where is y and y? This is 1. So remaining else are 0. That is how I will populate the table. Based on the given categorical column, I will populate the table in order to find out the distance. So now what? I have got this populated table. Now what? Now here, if you observe here, I have written instead of 0, 0, 2, 1, I have taken A, B, C, D. Okay, this is, now I have different types of distances present. So we come up with different type of distances when we are going for categorical columns. First, what is it? Binary Euclidean distance. So this talks about, what does this talks about? This talks about how dissimilar the records are. So there are different types of distance measures present for categorical columns. One is binary Euclidean distance. This talks about how dissimilar 2 records are. What do you mean by dissimilar? Which means it is neither no, which is similar. It is neither yes, which is similar. So when we see here, instead of numbers, I have taken alphabets here. So it is not no, which means this is also cancelled. It is not yes, which means D is also cancelled. So what are the left out ones? B plus C divided by all the values. So this binary Euclidean distance talks about how dissimilar 2 records were. Okay, so the next one that we have is simple matching coefficient. So this talks about how similar 2 records are. This is reverse. So what do you mean by similar? What do you mean by how similar 2 records are? Which means either it should be yes or no. Yes, no will be cancelled. So I have to cancel yes, no, which means this is cancelled. And also no, yes, this is cancelled. So what are the left out ones? A and D. So A plus D divided by all the values, which is A plus B plus C plus D. So how to calculate this for these 2 values? So B plus C. So this is A, this is B, this is C, and this is D. So in place of these alphabets, just replace these values. So B is 0, B means 0, plus C means 2, divided by 0 plus 0, A plus B plus C plus D, which means 2 by 3. This is binary Euclidean distance. And what is the next one? The next one is simple matching coefficient. What is the simple matching coefficient? A is 0 and D is 1. 0 plus 1 divided by again 0 plus 0 plus 2 plus 1, which is nothing but 1 by 3. This is how we will calculate the distance. This talks about dissimilarity between the records. This talks about the similarity between the records. And the last one that we have is Jacquard's index. So Jacquard says that if two people do not do something, which means if it is NN, if two people do not do something, they are not similar. If two people do something, they are similar. That is nothing but the Jacquard's index. So out of A and D, when we do A is nothing but no, we have to take it off. So what are the left out ones? D divided by, you have to again take it off A, B, C and D. So here what is the output? D is nothing but 1 divided by 3. Jacquard's index is also 3. These are the 3 different types of distances present when you want to calculate the distance in categorical data, which is binary data. So we will see a quick recap of the distance, then you can have a quick 10-minute break. So here, when I want to calculate the distance between records, when I am having numerical data, then I have different types of distance. I'll note it down in new sheet. Okay, I will tell you this point later. Okay, let's see what we have understood up to now. So here, if I am having numerical data or continuous data, everything is fine. And when I want to calculate the distance between two records or distance between the records, then I have multiple ways. What are the multiple ways? I can go for Euclidean distance, or I can go for Manhattan distance. Sorry. I can go for Manhattan distance, or I can go for Mahalanobis distance. Anything is fine. For suppose I have categorical data, not numerical now. I have categorical data and I want to find out the distance. How I have to find out the distance? I can find out based on 3 different types. One is binary Euclidean distance, and the next one is simple matching coefficient. And the third one that we have is Jacquard's index. This is how we can calculate the distance when we have numerical as well as categorical, that is nothing but binary data. If we are having mixed data, we will see it what to do. Before talking about that, let's have a quick 10-minute break. So everybody have a 10-minute break and get back. Okay, everybody, let's continue with the session. So we are discussing about the distance based on the different types of data. So in this current, like a example that we have taken before, for suppose I have created cluster based on the distance. Okay, fine. Now what happened? I got, for suppose if I have categorical data, now I got a new customer or a new person is getting added, or I have a new variant. Like what, for suppose he is using which type of car? Maybe he's using petrol variant, he's using diesel variant, and maybe he is also using diesel variant. For suppose I have got a new person, maybe person Mr. D. For suppose he is a graduate, yes, he's non-alcoholic, he's also not a vice president, and he is using an electrical car. Okay, now I got a new record and I got a new variant. Now, if I want to find the distance between A and C, we have more than 2 categories. I have more categories. If we have more than 2 categories, which means, see, there is a petrol, there is a diesel, there is an electrical variant. There are more than 2 categories in this particular column. That is not yes or no. There are no 2 variants, which is not a binary data. Then what I have to do? You have another case, which is how to calculate the distance for categorical, which is more than 2. So for more than 2 categories, the distance is 0 if both items have same category, which means if it is yes and yes, then the distance will be 0. If it is no and no, again the distance will be 0, which means same category. If it is yes and no, that will be 1. That is how we will calculate the distance if we have more than 2 categories. Okay, for suppose if we are having 2 categories, then this is fine, calculating the distance using any of the 3 methods. But if we are having more than 2 categories, the distance will be 0 if they are same. The distance will be 1 if it is different. Okay, so apart from numerical, apart from category binary data or category with multiple different categories, we have another case which is mixed data, which means you have a data set having both numerical as well as categorical columns. Then how to find out the distance? We will talk about it. Okay, let me delete this and we will go here. Distance metrics for mixed data. However, in certain data sets, you will have numerical as well as categorical data. In such scenarios, we will talk about how to deal with the distance. So we have mixed data. Then what you have to do is you have to perform the 3 steps that is present below. First, what you have to do, so instead of standardize, you can write normalize here. Okay, suppose we have a data set, which means which is having a numerical column. So numerical column, maybe I can take it as age column. So I have an age column present. So as we talked about age column, when we are having numerical columns with, for suppose expenses is there, that just like we have taken before, expenses is present. For that expenses column, I may have a 5-digit number or a 4-digit number, 6-digit number. So this may have impact on the overall distance. So in order to ignore that, you have to perform standardization or normalization. So what do you mean by normalization? Normalization, you already learned about it yesterday. You have a formula like x minus minimum of x divided by max of x minus minimum of x. So this is the formula for normalization. This you have to apply for each and every number present in this column. Then you will get normalized values. So what is this normalized values? Which means the minimum will be 0 and the maximum will be 1. After normalizing the numerical values, then what about the categorical? This is mixed data. It will have both numerical as well as categorical. So what about the categorical data? So for the categorical variables, just like gender, whatever the column that you want to take, you can take it. You have to perform one hot encoding. So what is one hot encoding? For suppose I have gender, male, female, 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 male, and so on. I have this categorical column. So how to find out the distance? In order to find out the distance, first you have to perform one hot encoding, which means there are 2 different categories. So you will have 2 different variables, male and female. Where there is male, you have to keep 1, otherwise 0, 0, 1, 0, 1, 0, 1, 1, 0, and so on. This is how you have to perform one hot encoding and categorical data. So on numerical values, you have to perform normalization to make it 0, 1. And on categorical data, you have to perform one hot encoding. And after that, everything will be in between zeros and ones. So here this is in between zeros and ones. These are also zeros and ones. For these values, you can find out Euclidean distance. This is how you have to find out the distance when you have mixed data. Columns like what? I have expenses column and I also have a column called as gender. So I have 2 columns. One is numerical and one is categorical. For these columns, if I want to find out the distance between two records, what I have to do? For this numerical column, I have to perform normalization. Normalization means you have the formula x minus minimum of x divided by maximum of x minus minimum of x. You have to perform this normalization on all the values present in the numerical column. Then you will get the values in between 0 and 1. After that, for this categorical column, you have to perform one hot encoding. So if you have n levels in your data set, which means n categories, a factor is having n levels, then you will get totally n variables in one hot encoding. So like gender is a factor. Why? Because it is a variable or a feature which is having limited values. Those values are called as levels. So male and female are the two levels. So two levels or two variables will get created. So now all the values are in between 0 and 1. Now you have to find out the distance using the formula, which is Euclidean distance. You already know about Euclidean, which is y2 minus y1 whole square plus x2 minus x1 whole square root. This is nothing but Euclidean distance. This is how you have to calculate the distance between two records for mixed data. So apart from these two steps, you have one more thing present. What is that one more thing? You have one more thing called as Gover's general dissimilarity coefficient. So what is this one? You can calculate the distance between two records. So see here. See here, there is one more thing present. So first, suppose imagine I am taking a data set. Suppose I am taking a data set here. Now, in my data set, I have 4 columns. Maybe I will take 5 columns. First, suppose I have income. I have income. I have age. Okay, right. I have income column. Income column is there. And I have one more column, which is age column. And I have maybe the third column, maybe I have gender. And I have education column, whether he's a graduate or postgraduate. These are the different columns present. Okay, so these are the different columns present in my data set. So we have to understand whether it is numerical data set or categorical or mixed. So here, see, I have a data set present here. Now, I have two values, 1 and 2. Now, for first person, the age is 32 and he is a male and he is a graduate. And the second person, the age is 30, he is also a male and he did post-graduation. Okay, these are the 4 columns. Now, if you observe, this is a numerical column. These 2 are categorical, which means this is a mixed data. And when I go for income, I have here, maybe the first person is having 80,000 income. And I don't know about the second person's income. This is not present in my data set. Now, this is k is equals to 1, which is the first column. This is 2, this is 3, and this is 4. Now I have to find out the distance. How can I find out the distance? Using this particular concept called as Gover's general dissimilarity coefficient. How can I calculate this one? So here, if you observe, in numerical values, you have to understand the concept, everybody. It is a numerical column. Age, I'm calculating age is a numerical column. So what is a numerical column? How to calculate the distance in a numerical column? Using Euclidean distance. So these are not larger values, so no need to normalize it. I will go for Euclidean distance. What is the Euclidean distance? y2 minus y1 whole square plus x2 minus x1 whole square to this whole square root. Now I will apply this for this particular column called as age column. So age, what are the values? I have only 2 values. So what I do is I will just perform 32 minus 30 whole square. So what is this one? 32 minus 2, which is 2 whole square 4. 4 square root is again 2. This is my distance for this numerical column, which is age. So here for age, the distance is equals to 2. How did I calculate the distance for age column? By using Euclidean distance concept. Why did I go for Euclidean distance concept? Why? Because my age column is a numerical column. Okay, fine. This is fine. Now, what about the second column, gender? What about the second column, gender? So gender, I have, this is categorical column. So what did we say? When the categories are same, the distance will be always 0. When the categories are same, the distance will be always 0. When we compare these two categories in education, these two are different, so the distance will be 1. Why? Because this is categorical column. So in categorical column, when two categories are same or more than two categories are same, the distance will be 0. If it is different, then the distance will be 1. Okay, so we have calculated distance for the 3 columns. Now what about the 4th column, income? So here the value is missing, so I can't calculate the distance, so the distance will be 0. Why it is 0? Because I don't have the second value, so I can't calculate the distance for income column, so the distance will be 0. So I have got the distances for all the 4 columns, and I have to understand the weight. So I will tell you the weight concept just in a bit. So before moving on to the weight, let us see the formula. So for Gauss general dissimilarity coefficient, what is the formula? That is, here I don't have I and j, I have only 1 and 2. So I will write, instead of I and j, I will write 1 and 2. So distance between the first record and second record, how to calculate it by using Gauss general dissimilarity coefficient? That is sigma k is equals to 1 to 4. Why? Because I have 4 columns. So 1, 2, 3 and 4. K is equals to 1 to 4. Wijk and Dijk divided by summation of k is equals to 1 to 4 Wijk. This is my formula. So how to understand about the weight? K is there, distance is also there. Then how to understand about the weight? Let's see, there is a point present here. So Dijk is the distance and Wijk is the weight. So usually weight will be either 1 or 0 depending whether or not the comparison is valid. What do you mean by comparison is valid? Let's see. Let's check it out. Wait. So here I will apply the formula of Gauss general dissimilarity coefficient and I will understand it. So here first. So first, what I should write here? So here it is equals to summation, which is first Wij is nothing but 1, 2, which means what I can write here is, so Wij, k is nothing but 1. For the first column, k is equals to 1 into Dijk means Dij1. So this is summation, you have to do it for all the columns, plus Wij2 into Dij2. So I will just give some space here. And what else? You have 4 columns, you have to do for 4 columns, plus Wij3 into Dij3, because k is equals to 3. Now I will replace k is equals to 4. Wij4 into Dij4. Okay, I got all the 4 weights divided by what? Summation of k is equals to 1 to 4 Wij, which means Wij1 plus Wij2 plus Wij3 plus Wij4. This is my formula. Now I have to substitute these values in the formula to understand the distance. How to get it using Gauss general dissimilarity coefficient. So here see. So first we have to find the weight. So what is weight? If 2 values are not present, all the values are not there, then weight will be 0. If all the values are valid, then weight will be 1. If you see for this income, the weight is 0. And for age, the weight is 1. For gender, weight is 1. For education, weight is 1 because the values are there. So based on this, I will replace these values over here. So how to replace it? See. So Wij, weight of the first one is obviously 0. 0 into something is again 0. Plus the second weight. The second weight is 1. 1 into distance. Distance is 2. 1 into 2. Plus the third also weight is 1 into distance is 0 again. So it is 0. Plus 1 into 1 again is 1. And divided by, you have to add all the weights, which means 0 plus 1 plus 1 plus 1, which is 3. So that is equals to 3 divided by 3, which is the distance between the 2 records 1 and 2 using the concept called as Gauss general dissimilarity coefficient. So this is how we calculate the distance in this formula. We won't manually calculate everything in real-time scenario, but this is how it will work. In order to understand the concept, I have given you an example. So what we have discussed up to now, we have seen, we will see it, wait, let me delete all these drawings. So here the distance we have talked about and weight also. So up to now what we have discussed, we have seen to calculate the distance between records, like what? If you have numeric values, if you have numerical columns or variables, then you have three types. What are the three types? That is Euclidean distance, Manhattan distance, and then Mahalanobis distance. So you have to understand these concepts so that you won't get confused when you are working in RapidMiner Studio. Without having knowledge of this, then you won't know the purpose of these things. Why do you have to do it and all? So you have to first know the theory, and then we have to move on to the like tactical part. Now, when you have categorical data, so in categorical, again, you have different types. If you have categorical data that is having two binary, then you can go for different types, like what? Binary Euclidean distance, binary Euclidean distance, and also simple matching coefficient. Simple matching coefficient and Jacquard's index. Okay. And if you have mixed data, multiple, which means if you have mixed data, which is categorical plus numerical, then what you can do, you can follow the three steps present. What are the three steps? First, you have to normalize the numerical column. You have to perform normalization on numerical column so that you will get all the values in between zeros and ones. And after that, you have to perform one-hot encoding. You have to perform one-hot encoding on categorical columns. After that, everything will be in numerical now. Whoever is doing, just ignore that one. So now you have to perform the third thing, which is calculating the Euclidean distance. This is how you have to perform when you have mixed data. Or else, what is the other thing that you have? That is Gover's general dissimilarity coefficient. So this is what we have learned up to now. So how to do it? What is the process present? I have talked about everything with the help of an example. I think everybody is clear up to here. So how did we calculate weight? If a value is missing in the column, the weight is 0. Otherwise, the weight is 1. Now, for all the distance measured, we have discussed all the things. These everything are only to calculate the distance between records. You have to understand this thing too. So in order to calculate the distance between records, if it is numeric, you have to go for this. If it is categorical, you have to go for this. If it is mixed, you can go for this. But if I want to calculate the distance between, if I want to calculate the distance between record and group, which means cluster, and group, then I can't go for these things. Then I have different concept. Let's see between that. That is nothing but the next concept, which is distance to calculate in between the clusters. So let's see what is present here. So in order to calculate the distance between record or like a record and a group, or between two groups, we will go for the concept called as linkage functions. In order to calculate the distance between two clusters, two groups, or a record and a group, you have to go for the concept called as linkage functions. Yeah, Venkatesh, what is it? Okay, I have to go for the concept called as linkage functions. So what about linkage functions? So there are different types of linkage functions present. The first one, that's single linkage. So single linkage is also called as nearest neighbor. So between the two clusters, what is the minimum distance present? That will be your distance between two clusters in single linkage. Let's see the example. So here, there are there is a scatter plot present maybe. So we are about to calculate. In here, what happens? In here, this is one cluster. Imagine this is one cluster. So imagine this is one cluster and this is one cluster. Now I have two clusters. Now what I do is, when I am using the single linkage function or single linkage, first what I will do is, for every data point from one cluster, I will calculate the distance to the data points in other cluster. Like from this data point to this one, this one, this one, and this one. And also from this data point to this one, from this data point to this data point, this data point, this data point. I'll do this for every other data point present in every cluster. So I will find out the distance. Out of all the distances, I have to see which is the minimum distance. So here, I will calculate the distance between every data point present in every record to every data point in other cluster. After finding out the distance, now I will understand what is the minimum distance. What is the minimum distance? So, okay. So here, if you observe, the minimum distance is present between, so this is a cluster, this is a cluster. When I calculated all the distances, the minimum distance is this particular distance. So this distance is nothing but now the distance between the clusters when you use single linkage method or single linkage function. Anything is fine. So in single linkage, we will calculate the distance between all the data points in one cluster to all the other data points in another cluster. By calculating that distance, we will check out which is the minimum one present. That will be your distance between the clusters in single linkage. So apart from single linkage, you have the second one called as complete linkage. So what is this complete linkage? So in complete linkage, this is also called as farthest neighbor. This is reverse of this one. Here also imagine you have two different clusters. Here also I will calculate distance from one data point in one cluster to another data point to all the other data points in another cluster. Now here I will take the maximum distance one. So whichever the data point is having the maximum distance, that will be your distance between the clusters when you are using complete linkage. So let's check it here. So see. So let's see. So from this data point to this data point, for all the other data points, I have calculated my distance. Now out of all the distances, I have to calculate the maximum one, which will be this one. Now, this is your distance between the clusters when you are using complete linkage. So, when we are calculating distance between individual records, then you have different functions which we have discussed before. But when we want to calculate the distance between record and a cluster or between two clusters, you have different types of functions called as linkage functions. Within that linkage, you have the first one called as single linkage, which is also called as nearest neighbor, which is the minimum distance out of all the distances present. And the second one that we have is complete linkage. It is called as farthest neighbor. Here, this is the maximum distance between the members of two clusters. Apart from these two, there are also other linkage functions present. The third one that we have is average linkage. We have another type of linkage called as average linkage. Here you will find the distance between one data point to all other data points, and you will take the average of distances of all these data points. So here, see. Here, these are two clusters present. There are two clusters. One is this one, and one is this one. After that, I will calculate the average. So out of all the averages, whatever that I found, that is the distance in average linkage. This is easy, which is average value. And coming to the fourth one, which is centroid linkage, here also you have an example of two clusters present. Here you have an example of two clusters present. Here we take the average of data points in one cluster. So when I take the average of data points in one cluster, I will get one centroid here. And I will take average here, I will get another centroid. The distance between these two centroids will be your distance in centroid linkage. So here we have discussed four different types. One is single linkage, which is nearest neighbor. And second one is complete linkage, which is farthest neighbor. And third one is average linkage. And fourth one is centroid linkage. So these are the different linkages, functions, or different methods that we can use in order to calculate the distance between two clusters or between one record and another cluster. Okay, so let us see an example present here. Okay, before moving on to that example, let's see an example here. Okay, let's check out an example. First, suppose you have data points like what? There is one data point here, which is D1, and another one is D2, which is present here. And there are three more data points, D3, D4, and D5. Okay, now I imagine like these three belongs to one cluster. Okay, and after that, this is very farther. But suppose in this case, if I use single linkage, you have different linkages, right? I want to find out the distance. Now, but suppose if I use single linkage, now you find the distance which is closest. So when I just see, this is the closest to this one. So these will make a cluster. So based on that, you can use different types of linkage functions and you can get the distance. Okay, so what is it that we have learned for now? We have understood like when I want to find the distance between two clusters, I have four different types of linkages present. One is single, second one is complete, third one is average, and fourth one is centroid. Apart from these three or these four, we have another linkage called as okay. So apart from these four, you have another type of linkage called as wards. So wards, it is the mostly used one and it is considering the concept called as loss of information. It is considering a concept called as loss of information. So here it is given an example for this one. Let's check it out. So So what method is there? Here we will like it minimizes within the cluster variance. Okay, we will see that later. So here it is based on a concept called as loss of information. So suppose you have a set present. So you have here a lot of numbers like 2, 6, 5, 6, 2, 2 and so on. These are present. Now, when it comes to deciding the number of clusters, and we talked about hierarchical clustering and what happens in hierarchical clustering. At start, we treat every individual value as a separate cluster. So here totally, when I have this particular step, which is step 0, I have totally 11 number of clusters. So I have here totally 11 number of clusters, which means at stage 0, we will treat each and every value as a separate cluster. Now, if I have to calculate the loss of information, so how can I calculate the loss of information? This loss of information is calculated as error sum of squares. This loss of information is calculated as error sum of squares, which means what? The error sum of squares is nothing but each value minus mean, which is average value, whole square. So the sum of squares, error sum of squares or loss of information is calculated using the formula each value minus mean, which is average whole square. So if I calculate for this particular step 0, if I calculate mean for this value, what is mean? Mean means average value. What is the average? 2 by, so this will be 2. So 1 by 2, which, sorry, this is 2, this will be 6, this will be 5, this will be 6, this is 2, this is 2, and so on. So this is how you will get the value. For suppose, if I calculate this one, which means 2 minus 2 whole square plus 6 minus 6 whole square plus 5 minus 5 whole square and so on. Everything is 0. 0 plus 0, 0 plus 0, which means 0. So when we are considering each value as an individual cluster, which is having total 11 number of clusters, the loss of information is always 0. Okay. For suppose, what I have is, when we take the mean of a single point, okay, sorry. Say another extreme, you have these data points. So here, if you see here, all these data points I have grouped together into one cluster in step 4, I guess. So I have just mixed them all together into a single cluster. Now I have to find out the error sum of squares in order to understand the loss of information concept. So how can I calculate? First, you have to calculate the mean, which is calculated the average. Now, calculated into one cluster here. Now I want to find out the loss of information, the error sum of squares. So each value, so 2 minus 2.5 whole square plus 6 minus 2.5 whole square and so on. If I do this, I got a value which is 50.5. This is huge loss of information. The value is very more. I don't want to go for this type of cluster. If example of converting these entire values into 3 clusters. When I've taken into 3 clusters, this is one cluster, this is one cluster, this is one more cluster. If I have taken that, I want to understand what is the loss of information present. So for this, I have to calculate mean, that is 2 plus 6 plus 5 divided by 3, which means what? 6 plus 5. Okay, so 6 plus 2 is 8, 8 plus 5 is 13, 13 divided by 3. This is the average. So how to calculate the error sum of squares for this one? That is 2 minus 13 by 3 whole square plus 6 minus 13 by 3 whole square and so on. For this one, you have to again calculate the mean. 6 plus 2 plus 2 plus 2 divided by 4. 6, 12, 6, 8, 10, 12. 12 by 4 is 3. Which means I have to calculate here 6 minus 3 whole square plus 2 minus 3 whole square. That you have to do for every other cluster. When you do that, I got the loss of information that is 23.7. This is less when I compared with the cluster which is 0. Sorry, when I have one number of cluster, the loss of information is more. But when I have taken 3 clusters, the loss of information is comparatively less. I have taken one more case. What is this one more? So here I have taken 4 clusters. So I've taken 4 clusters here, and when I just calculate the mean for every cluster, and when I've applied this formula of error sum of squares, I got the loss of information as 0. I got the loss of information as 0. So what you have to understand is, wherever you are getting the less amount of loss of information, that is the best way of clustering, according to the concept called as Watts method. According to the other method, apart from the 4 linkage functions present, which is Watts method, wherever the place where you have less number of loss of information, that is the number of clusters that you have to create. So in all of the 4 cases that you have taken, when you have 11 and 4, you got the loss of information is 0. But this is huge amount of clusters. So instead of going for 11, I can go for 4. So this is the best way that you can cluster this data using Watts method. So this is called as Watts linkage. This is called as Watts linkage. Now let's see what is present next. So see here, there is another example present. So there are 5 items totally and 2 input variables x1 and x2. Now we have plotted it. How we are plotting it? See here. Here, the first one we have the data point 1, 1, which is this one. 1 and 1. Now the second one is x is 2 and y is 1. x2 and 1. This one. This data point. Now 4 and 5. This is 4 and this is 5 here. The third one. And 7 and 7. This is 7 and 7. The fourth one. So this is 1. This is 2. This is 3. This is 4. And where is fifth one? 5 and 7. This is the fifth one. So this is how we are plotting this one. Okay. So I have 5 data points. And I've just got this data over here. So see, it is getting for all the values, all the other values. So 3, 4, and 5. Okay, I've got it. Now what? Now what? So here, now we are finding the Euclidean distance matrix. You already know what is Euclidean distance. What is it? You have to find out the distance between 2 values which are to be numerical only, because this applies only for numerical values. If the 2 values are numerical, you can go for any of the distance measures present. One, you have the mostly used one, which is Euclidean distance. So Euclidean distance is calculated as the square root of y2 minus y1 whole square plus x2 minus x1 whole square. So if I have to work out this for every value, so here see, I want to calculate the distance between 1 and 1. So that is obviously 0. I will just show you the example showing 2 and 1. I want to calculate the distance between 2 and 1. So 2 and 1. So here see, that is square root of, calculate. This is x1, this is x2. This is y1, this is y2. So 1 minus 1 whole square plus 2 minus 1 whole square. So how much is it? 1 minus 1 whole square is 1 plus 2 minus 1, 1 again 1. So square root of 2. Sorry, wait. So 1 minus 1 is 0. Square root of 1, which is 1. So here, that is how you will calculate the Euclidean distance between two data points. I will show for this one. See, I want to calculate the distance between 3 and 1. 3 and 1. So between this and this one. So here, this is x1, this is x2. This is y1, this is y2. Now calculate the distance. Square root of y2 5 minus y1 1 whole square plus 4 minus 1 whole square. 4 minus 1 whole square. So 5 minus 1 is 4. 4 square plus 3 square, which is 25, which is equals to 5. This is how you are creating a Euclidean distance matrix for every data point by using Euclidean distance. Okay, I've got this table. Now what? Now what to do? I will delete this drawings, wait. Now what? Here see, out of all the distances present apart from zeros, the minimum distance is 1. So whatever the minimum distance is present, what you have to do, we need to, according to the single linkage, you have to find the least distance and you have to merge both. So what you have to merge? You have to merge 2 and 1 because that is having the minimum distance, 2 and 1. So how to merge this? So see here, these became a single cluster now. Now you won't have individual. This is named it as A. So you will have A, 3, 4 and 5. There is no 1 and 2. See here. You will have here A, 3, 4 and 5. Now again, same thing. What you have to do? You have to again calculate the distance between A and A, 3 and 3, 4, 4, 4, 5 and so on. So how to calculate distance here? Here, A is there. I want to calculate distance between 3 and A, which means 3 to 1 and 3 to 2. How to calculate it? So you already know 3 to 1 is 5 and 3 to 2 is 4.5. So out of these two, which one is the minimum? 4.5 is the minimum. That will be your output here. So similarly for the other cells also, when I want to calculate for 4 to A, which means what? From 4 to, from 4 to 1 and from 4 to 2, I have to calculate the distance. So 4 to 1 is 8.5 and 4 to 2 is 7.8. Out of these two, 7.8 is minimum. That will be your output. This is how you will calculate. And out of these, again, you have to calculate the minimum. 2 is the minimum, which is present for 5 and 4. Now, these will be clustered together into B. Now, what you will have? You will have A, you will have B, and you will have 3. So, see here. Now, this is the minimum. Now, you will have only A, B, and 3. That is how you have to just find out the distance. So, see, I will erase this one. So, now again, in this particular concept again, you have to find out the distance again, which means what? I will just work with yellow. So, here I want to find out between 3 and A. 3 and A means again same. 3 and A is 4.5. It is again 4.5. And I have to calculate between, I will show you this one, see. B and 3. So, B is nothing but 5 and 4. B is nothing but 5 and 4. And 3. So, I have to calculate between 3, 5 and 4, 3. So, 3, 5, 3. 3 and 5, I don't have 5, 3. This is 2.2. And then what? 4, 3, which is 3.6. Out of these two, which one is the minimum? 2.2 is the minimum. So that is how you will calculate the distance. And after that, if you see out of all, these two are the minimum, which belongs to B and 3. So now 3 will be merged into B cluster. Now you don't have anything. You will have A and B. That's it. So see here. So see, these will be merged into one cluster. And after that, you will have only A and B. This is now you will work on the hierarchical clustering process, which is single linkage. In single linkage, always you will go for the concept called as minimum value, which is nearest neighbor. Out of all the distances present, what is the minimum? You have to check it out. Now let's see how to do this agglomerative clustering in RapidMiner Studio. Let's check it out, that concept. Before checking out that concept, let's have a quick recap of what we have learned. So we will talk about the cluster evaluation in next session. So first, what we have learned for now. So now, today, we have talked about first the supervised learning. We have talked about supervised and unsupervised. Supervised is nothing but we are having output variable as well as input variables in our historical data, and we are predicting the model. So here what we are doing, out of 100% of data, we are taking 80% of historical data into training data set. Why we are doing that? In order to train the model based on a machine learning algorithm. So why we are training based on machine learning algorithm? In order to find out the relationship between output variable and input variables. How? Using a mathematical equation. After that, the rest of the 20% we will take it into validation data set, which is also called as development data. So in this, we will apply the mathematical equation, and after prediction, we will get the predicted outcome. So here what happens? How you're getting the predicted outcome, which is the accuracy? Here, basically, the actual values, the predicted values are compared with the actual values. Based on that, you will get the accuracy. If the accuracy is good, you will apply the mathematical equation on the new data or the future data. And you will just give the inputs, and after applying the machine learning, which is the mathematical equation, you will get the output, which is nothing but the predicted outcome. This is the process that happens in supervised learning. So what is unsupervised then? What is unsupervised? There is another one which is unsupervised. In unsupervised, you are not predicting anything, and in the historical data, you don't have any output variable. Why is not there? Why is not known here? Okay, now in unsupervised learning, what we are doing, we are taking the historical data, we are applying a machine learning algorithm in order to understand the rules and patterns. In order to understand rules and patterns. And based on those rules and patterns, when I have new data, based on this, I will make the predictions and I will understand the predicted outcome. This is nothing but unsupervised learning. And supervised learning is also called as predictive modeling, and unsupervised learning is also called as descriptive modeling. And after that, the most important thing we have learned is the concept called as hierarchical clustering. The concept called as hierarchical clustering. So in hierarchical clustering, you have agglomerative and divisive, two types. Clustering is nothing but combining homogeneous or related groups or records together. So here, this comes under unsupervised because we don't have any output variable and we are not predicting anything. So in here, before talking about the hierarchical clustering, we should understand what are the distance properties present. What are the distance properties present? So what are the properties present? So first, suppose you have two data points, I and j. So always the distance between the two data points will be positive. That is not negative because it is always greater than 0. And the distance from one specific data point to the same specific data point will be always 0. And the symmetry is present, which is the distance from I to j will be always equals to the distance from j to I. And coming to the last one, triangle inequality. When we sum together the distance between two sides, it will be always greater than or equal to the third side. It is not less than. That is the third case. Okay, this is nothing but the distance properties. After that, coming to the distance metrics. Coming to the distance metrics. So distance metrics, how to calculate the distance? So when I am about to calculate the distance, if you are having a single variable, then you can simply go for a box plot. If you are having two variables, in order to perform the clustering, you can go for a scatter plot. If you have more than two variables, then you have a mechanism called as multivariate distance. You have a concept called as multivariate distance, within which we will compute the distance. How we are computing the distance? You can compute distance between records. And you can calculate the distance from record and a group, which is a cluster, or you can also calculate between groups. You can also calculate between groups. Okay, this is fine. Now, when you are calculating the distance between records, what are the other further present? So when I am about to calculate distance present between records, I have to check whether I have the columns are numerical or not. If they are numerical, I have Euclidean distance, Manhattan distance, Mahalanobis distance. And if I am having the columns, which is categorical and binary, then I have binary Euclidean distance, simple matching coefficient, and Jacquard's index. If you have mixed data, which is numerical and categorical, then you can go for the 3 steps. That is, first you have to normalize. Then the categorical columns need to be performed one-hot encoding. And the third one that you have is you have to identify the Euclidean distance. Apart from these 3, you have Gover's general dissimilarity coefficient. So if you are calculating the distance between records based on the column type, you will perform any of it. Now, if you are having, or if you want to perform, understand the distance between the records and a group, or the distance between 2 groups, then you can go for the concept called as linkage functions. In linkage, you have 4 types. That is single linkage, complete linkage, average linkage, and centroid linkage. But the most commonly used one is WORDS. So in WORDS, we will go for again Euclidean distance matrix. You will calculate the distance based on that the clustering happens. So this is what we have a brief understanding about. Now let's check how to perform agglomerative clustering in RapidMiner Studio. So we have learned a lot of concept, but it takes only 5 minutes to perform it in this particular tool that we are learning. Why? Because everything is drag and drop interface. We don't have to do anything. So let's see what happens there. So let me open RapidMiner Studio here. So here I'm going to perform Okay, so here I'm going to perform this agglomerative clustering in RapidMiner Studio. So you already have the data set, which is empty cards present in your LMS. I'm going to use that empty cards. So that is a CSV file. So I'm going to use the operator read CSV. So because the file that I'm going to work on with is a CSV file, so I'm using the operator read CSV. So double click on this operator in order to import it. And I have empty cards dataset present. So I want to connect with this one. Click on next. I don't want to change anything. So there is no problem in my formatting. So I'll simply click on next. And here also there are no problems. Data types are properly present. I'll click on finish again. Now I got the data set. If you want to see, you have to execute the process. Connect your output port to the response port and execute this process. Okay, now I got totally 32 records and 11 columns. Now what? Now what is it? Now I want to perform clusterative clustering on only selected columns. I don't want to perform on all the columns. I don't want all the columns. Now what I do is, I will take select attributes. I will take select attributes. So in select attributes, you can choose whatever you want, a subset or anything you want. Any of the columns that you want. Okay, maybe I will take here a subset of attributes. What are the attributes that I want to choose here? So everything is fine. I don't want to change anything. Okay, fine. I will just choose all the columns. Now I will perform the clustering called as agglomerative clustering. So when you just type your clustering name in the operator's search bar, you can see here agglomerative clustering operator present. Just take it into the process. So always remember, you have to make the connections. Just make the connections. Just make the connections. And just connect this to the output, which is response port. If you want to perform clustering, so see here. If you have single link, whatever the complete link or average linkage, you can go over here. So why this is showing linkage functions only? Why is it? When did I talk about linkage functions? When we want to find out the distance between 2 clusters. So I want to find out the single linkage. I want to go for single linkage. I'm not changing anything. So now I will execute this process. So you can connect this one to this one as well and execute the process. So here I did not check the parameters. Maybe I will choose all and execute the process. So now if you see here, this is hierarchical cluster modeling that I have done, and I got totally 63 clusters. So here, if you see here, how your graph is going to look like. So this is your graph. So here, see, this is how your graph is going to look like. This is how. I'll zoom it a bit. So this is how you can zoom it in. So this is how clustering happens. But if you want to see it graphically clearly, you can go for the dendrogram. Dendrogram is a type of visualization where you can see how the clustering happens clearly. So see, this is how the clustering happened. But I feel like this is a lot of clusters. I don't want such lot of clusters here. So first, I've taken MD cards. So here, if you have, okay, I don't want the select attributes because I've chosen all the columns. I'll choose agglomerative clustering. I'm using single linkage. I don't check on anything. So I will execute the process. Now I got totally 63 clusters. I feel like that is a lot of clusters. I want only 3 to 4 clusters. Now what I do is, I will use one more type of operator called as flatten clustering. So I'll take flatten clustering here and see, I will make the connections for this one. Clustering output and this one also, and this is also same. So whatever that I'm taking here, I'm executing this process by making the connections between operators. In flatten clustering, I want maybe 4 clusters only. I don't want 63 clusters. I want 4 clusters and I will execute the process. So see, now there are totally 4 clusters. If you want to see what are the clusters and what are the data points, you can go for folder view. So in cluster 0, these are the data points. In cluster 1, these are the data points. In cluster 2, these are the data points. In cluster 3, because I have taken 4. And the graph will look like this: 0, 1, 2, 3, and 4. These are the 4 clusters that I've created. And if you have more number of clusters, you can see the dendrogram. If not, you can't. So this is how, using a single operator, you can perform agglomerative clustering in RapidMiner Studio. What is that operator? That is the name of the clustering itself, which is agglomerative. So see here. So segmentation includes a lot of different operators, but we have discussed only one type of hierarchical clustering, which is agglomerative. In the next session, we will talk about the further things and we will see how to do it in RapidMiner Studio. So I have used the dataset empty cars, which is having 31 records, and I want to just create 3 or 4 clusters in my data set using agglomerative clustering. So I have taken this one, but it is showcasing by default 63 clusters. In order to reduce those to 4, I have used one more operator called as flatten clustering. Now I got totally how many clusters? That is 4 clusters, which you can see in the folder view of results view in RapidMiner Studio. So this is how everything is present. You can check it out in the mind map itself. We have started discussing about model building. So machine learning, supervised learning, we will split the data, and training, validation, and testing. And unsupervised learning, you have different types within which we are talking about clustering or segmentation, within which you have again different types. Partition-based clustering, we will talk about other things which is k-means in the session which will be on next Friday. So everything about others that we have missed out, we will see in next session. So supervised is predictive modeling and forecasting and evaluation and how to build, how to deploy your model. Everything we will see in further sessions. So I think the session is helpful for you, everybody. We will meet again on next Friday on exact same time, which is at 10 a.m. So thank you, guys.